Hello, good morning guys, good morning. Welcome to BYJU'S Exam Prep. So I hope your preparation is up to the level. Very good morning, very good morning. So quickly join the session and please do let me know whether my audio and video is all perfect. Good morning Shubham, good morning Surya, good morning Jitender, Panchal, Shankar, Vignesh, Bhargav. So all excited for this another subject, another marathon. GATE 2022, your target. And I hope so this marathon sessions will be really very helpful so that you can secure your dream PSU. Good morning guys, good morning, good morning. Sorry for that delay because it was raining outside, so I got stuck in that traffic jam, that's why. Good morning, good morning, good morning. Crystal clear, sab sahi hai, bilkul badhiya, bahut badhiya, very good morning. So today we'll be starting with the industrial part 1, right? अरे यार एक बार लाइक कर दीजिए, प्लीज डू लाइक दिस सेशन एंड प्लीज डू शेयर दिस वीडियो टू ऑल ऑफ योर फ्रेंड्स सो दैट दे कुड ऑल्सो ज्वाइन दिस सेशन, दिस मैराथन सेशन which is planned for you guys only, right? Good morning. Yes, back on the smart board as you all requested that marathon should be on the smart board. So here we go. All the faculties will be taking all the marathon sessions on this smart board only. Good morning, good morning, very good morning. Okay. So how are your preparation going on? I hope so. 2 subjects is being over. Fluid mechanics and theory of machine. Very major, 2 major subjects is being over. Okay, very good morning. Okay, fine. Because these 2 subjects are very, very important and we'll be starting with industrial engineering so that we can understand the major topics. And also I'll be showing you the previous topics from where the GATE examinations regularly asking and what is the percentage of your topics that is being asked from this particular subject. Okay, सब कर दिया है. चलो good morning, good morning. चलो let me start. चलो let's start this session, industrial engineering part 1, and we will be having a clear clarity. Because industrial engineering is more sort of a mathematical subject. So unless and until you're not solving the example, you won't be able to understand this topic. Right? Okay, so we'll be having the clear explanation with the help of the example only. Right? Chalo, let's start the session. I hope so you know about me, and make sure everyone is joining this Telegram channel where I'll be sharing the PDF of this session also. Okay, I'll be sharing the PDF of this session also in this particular Telegram channel that you are seeing on your screen. Learn with Suraj. Right? Okay. So marathon sessions every day going on, and today in the evening Dheeraj sir will be joining with a very important subject, that is production engineering. So I hope so you are all excited for all the faculties, and let's start with industrial engineering. Let me tell you about the previous I would rather say from 2003 to 2021 or 2005 to 2021, right? Last 15 years. What was the weightage? If you see number of questions that is being asked from this particular subject is 3 to 4 questions, approximately 5 to 7 marks will be the weightage, right? And the most frequently asked topics from this particular subject is inventory, very very important. Okay, linear programming, forecasting, Pert CPM, sequencing and queuing theory. These 6 topics is really very very important, because from industrial engineering, from GATE examination point of view, you should be having a clear clarity of these topics that you're seeing on your screen. Okay, fine. So make sure you're not skipping out any topics, and we'll be covering entire syllabus, right? And majorly be focusing on these topics which is really very important, and this is being asked from the previous GATE examinations. Okay, so make sure you are having 120% clarity of these topics that you are seeing on your screen. Okay, so today we'll be covering inventory. Today I'll be covering inventory, Pert CPM and sequencing. These 3 topics will be covered in today's session. Okay, from basics to examples, everything will be covered. These 3 topics I'll be covering in today's session, right? Okay, inventory control, Pert CPM and sequencing. And tomorrow I'll be covering the rest topics. Majorly important topic is linear programming, forecasting, queuing theory, and after that, if we're having the time is allowing us, then definitely we'll be going with the next topics. So let's start with the first topic, that is Pert CPM. Let's start with the first topic, that is Pert CPM. Okay, fine. Telegram channel name is Learn with Suraj, right? LEARN with SOORAJ. You'll be getting the PDF of this particular session in that particular channel. So first topic, the most important topic, that is Pert CPM. I hope so everyone knows about the difference between Pert and CPM. Anyone who can tell me in the comment section quickly, what's the major difference between Pert and CPM? Yes, quickly. What is the major difference between Pert and CPM? Look, any activity, if you know the time of completion, let us suppose there is an activity A and you know that it is being completed in 10 days. That means this activity has been previously done by any candidate or any person has completed this activity. So you know the time of completion of this activity. But let us suppose you know there is an activity A, but you exactly don't know what is the time of completion of this activity. So based on that, what we do the Pert analysis. Okay. Fine. So Pert analysis is being done to those activities whose time of completion you don't know, right? It's a probabilistic approach. But if I talk about critical path method or CPM, it is being done on those activities whose time of completion you know. Okay. Let us suppose there is an activity which takes 10 days. That is, in any condition, it will take 10 days. So that means that is your time of completion you know for that particular project. Exactly. So the major difference is usually in R&D, in research and development, we are using Pert analysis. Okay. In research and development, you are using Pert analysis. But if I talk about critical path method, we are using in those activities where the time of completion you know. Okay. So can we say the CPM is more sort of a deterministic approach? Okay, and if I talk about Pert analysis, it is more sort of a probabilistic approach. Right? Is this clear? Fine. Give me a minute. Just 1 second. Okay, yes, थोड़ा सा AC स्टार्ट करना पड़ेगा because now माहौल गर्म हो चुका है and everything, students are really excited for this topic, so I thought let's switch on the AC. Okay, chalo. So what we were discussing was Pert analysis is being used where we don't know the time of completion of an activity. Okay. And the CPM method or the critical path method is being used where you know the time of completion of an activity. That is why we call this as a deterministic approach, and this is we call it as a probabilistic approach. Okay. Now, if you don't know the time of completion of an activity, then how we can calculate the time of completion of any activity? Because let us suppose there's an activity A. You exactly don't know what's the time of completion. Sometimes the same activity is taking 5 minutes. Same activity is taking 50 minutes. And same activity is taking, let us suppose, 15 minutes. Okay. Then how we can identify what is the exact time of completion of that activity? For that, we'll be using a very basic method where the Pert analysis is using 3 time estimates. Is this clear? So where the Pert analysis basically is using 3 time estimates, in which we will be having 3 time will be given for an activity, right? We calculate based on the probabilistic approach the exact time of that completion. I will get to say 90% of the time this will be the time of completion of an activity, because in some condition it is taking 5 minutes, in some condition it is taking 50 minutes, and in some condition it is taking 15 minutes. Right? Exactly. Fine. So can anyone tell me in the comment section what are these 3 time estimates? Yes. Can anyone tell me in the comment section what are these 3 time estimates? Very good, Vignesh. It's basically your optimistic time optimistic time, pessimistic time, and your most likely time. Okay, but the same thing is not applicable in CPM, because we know exactly what is the time of completion of an activity. But in case of PERT analysis, the activity completion time you don't know. So based on that, what we do, we try to calculate 3 different conditions. Now, can anyone tell me what is optimistic time? Optimistic time is basically when everything is in our condition or in our favor. Let us suppose you have studied only 10 topics in the mechanical engineering. Okay, you have studied 10 topics in the mechanical engineering, and luckily what has happened, all the 10 topics was asked in the GATE examination. Okay, you left out the rest, 30 topics is being left out, but what you have done, you have only studied 10 topics. That means everything is in our favor. You secured 100 after 100 in the GATE examination. So tell me, do I will be taking the most largest time or the least time for completing an activity? That means if everything is in the favor, that means it will be the minimum time. Okay, so can I say it is a minimum time to complete an activity when everything is according to our favorable condition? Let's see the opposite of that, pessimistic. Now, the word pessimistic is a negative meaning. ऐसे सपने में होता है डेफिनेटली, तभी तो इसको बोलते हैं इट इज अ प्रोबेबिलिस्टिक अप्रोच. It is not practically feasible. Okay, that everything you have studied 10 topics and that 10 topics is becoming the GATE examination. And the vice versa, you have studied only 10 topics and the GATE examination एक भी question नहीं पूछा. Not a single question is being asked from that 10 topics. That will be pessimistic. Okay, so that will be the maximum time to complete an activity. Okay, exactly. Now the last one is the most likely, that is on an average this will be the time of completion of an activity. That is the most likely time. Fine. Yeah. So PERT analysis, that is program evaluation review technique. Already I have mentioned about these points. Yeah. 3 time estimates that we have already studied. Optimistic time is basically, it is denoted as TO. It is a minimum time to complete an activity when everything is going according to the plan, right? Second one is pessimistic time. It is a maximum time required to complete an activity when everything goes against the plan. This is also very rare. ये हो सकता है क्या? This is that practically feasible that you have studied 10 topics and not a single question is being asked from that 10 topics. Probability थोड़ी ज़्यादा है. It's like slightly more probability than that of optimistic. But yes, practically if I say, it is not, both are not practically feasible. We can say we can have less than 5% or 10% will be the probability that this will be the time of completion of an activity. But 99% of the time or 95% of the time, you will be having the most likely time to be the time required to complete an activity under normal conditions. Okay, under normal working condition, this will be the time of completion of an activity. Is this clear? Is this clear? Now, the main challenge is, sir, in critical path, you have just now said, sir, we know the time of completion of an activity, but here we don't know the exact time of completion of an activity. Then how to calculate? We simply use the simplest method. The time of completion of an activity is equal to optimistic time plus 4 times of most likely plus pessimistic time divided by 6. Okay, this is the time of completion of an activity, that is T is equal to TO plus 4TM plus TP plus 6. Very frequently asked question from this particular segment. We'll be taking one example, and from that example I'll be explaining float also, float, independent float, total float, everything, free float, everything will be discussed in that particular example. Okay. Is this clear? Fine. Now this is for an activity. You have calculated the time of completion of an activity. So there will be various activities in a complete project. there will be multiple activities. So what we do, we try to calculate for individual activity this time of completion for an activity. And by using this, we'll be drawing the critical path. Now you'll be saying, sir, critical path is a different method and how you can collaborate with a PERT. Basically, this is a slight confusion that many students are having. Dekho, critical path. Now, what do you mean by critical path? Can anyone tell me what do you mean by critical path? Yes. Yeah. Yes. Critical path. What is critical path? Critical path is basically the maximum time required to, it is the longest time taking path in a project. Okay. It is a maximum time consuming path from first event to the last event in a network diagram. There is one more definition. Please tell me in the comment section, am I correct or not? It is a minimum time to complete a project. Is this correct? If I write a statement like this, it is the minimum time required to complete a project. Am I correct or wrong? Because one time I am saying it's a maximum time, and second I'm saying it is a minimum time required to complete a project. So is this correct or not? Is this correct or not? Please tell me in the comment section. Because both ways, in one statement I'm saying it's a maximum time, in the second statement I'm saying it's a minimum time. How this is correct? Exactly. This is absolutely correct. In a complete project or in a complete network, this will be the maximum time consuming path from first event to the last event. But if I talk about the project perspective, this will be the minimum time required to complete a project. Is this clear? This will be the minimum time to required to complete. Let us suppose I'm having an activity like this: 1, 2, 3, 4, something like this. Okay. Let us suppose this time of completion is, let me take, this is 2, this is 5, this is 7, and this is 3. Okay. So can anyone tell me what is the critical path? We are having 4 activities. Okay. This is activity A taking 2 time. This is 5 times, 7 time, and 3 time. Okay. So tell me what will be the critical path. This is very basic. You start from 0. From 1 to 2, it is a single path. It will be taking 2 time. From 2 to 4, it will be taking 7. Okay. If you go by this way, this is 1, 2, 3. It will be taking 7. 7 plus 3 is 10. So what will be the time of completion? Okay. So the critical path will be this one. 1, 3, 4 is the critical path. Okay. 1, 3, 4 will be the critical path, right? And what is the time of completion? So this is capital TE, that is equal to, let's say I'm taking in days. So it will be the minimum time to complete this entire project will be 10 days. The minimum time to complete this entire project will be 10 days. Is this clear? Fine. And the critical path will be 1, 3, and 4. And this is the longest time, because if you go by 1, 2, and 4, it will be taking only 7 days. But if you go by 1, 3, and 4, it will be taking 10 days. So it is a maximum time consuming path, and also it is a minimum time required to complete a project. Okay, is this clear? Now my question is why we are calculating this critical path? Why we are calculating this critical path? Anyone? We are calculating this critical path in order to identify what are the critical activities. Is this clear? Okay. The main objective. Fine. the main objective of calculating this critical path is in order to identify the critical activities. Let us take a very basic practical example. Okay, let us suppose in a power plant, we're having 4 activities. Your wagon tippler. Okay, let's say we are having an activity of wagon tippler. Okay, we are having an activity of boiler, right? We are having an activity of ash plant, right? We are an activity of let us say cooling tower. Fine. So what has happened as there are 4 activities. Now why we are calculating these critical activities, we need, this is in construction phase. You are constructing a power plant and these are the critical activity. There are other activities also. Let's say like in total there are 10 activities. Out of this 10, these 4 activities is on the critical path. Now by identifying the critical path activities, we can alter or change the time of completion of an activity. How we can do that? Look, let us suppose it is taking 5 days, it is taking 10 days, it is taking 2 days, and it is taking let us say 8 days, right? So let us suppose if I want to decrease the time of completion, at present it is having 15 plus 2 your 17 plus 8, that is 25. Okay, at present it is taking 25 days. Okay, at present it is taking 25 days. Now if I want to complete this complete project by 20 days, or 21 day, right? So what we do, we try to identify the critical activities, because if you change the time of completion of these activities on the critical path, we can drop down the time of completion of the entire project. That is the main significance of identifying the critical activities, and this process we call it as, everyone, yes, this process we call it as crashing. Okay, this process we call it as crashing. What do you mean by crashing? Crashing simply means, let us suppose there's an activity A and it is taking 10 days for completion, but you want this activity A to be completed in 6 days. Then what will be doing? You will be increasing the resources, you will be adding some manpower, you will be having some additional machineries, you will be having more supplies, so more resources will be supplied, so that you can now complete the same activity which was taking 10 days, now you are completing in 6 days. So basically you are increasing the cost, but it's not always mandatory. It is not always mandatory that by having that additional cost increment, there is some probability that by reducing the time of completion, there could be a possibility that you can reduce the total cost of the project. How this is possible? That will be taking with the help of an example. Okay, so it is not always mandatory that if you are reducing the time of completion, because definitely earlier the project was completing is 25 days. You want to cut short this by 20 days. So definitely the cost gonna increase. The resources, you increase the machines, you will be increasing the manpower, you will be recruiting some more engineers to complete that project. But now what has happened, by doing so, there is also a possibility that you can reduce the total cost for the entire project. Is this clear? So this analysis we call it as crashing. So this analysis we call it as crashing. Is this clear? This analysis we call it as crashing. Is this clear, everyone? Okay. Yes, so now we'll be understanding one by one, by taking an example, how we can identify the critical path and how we can calculate the probability. Now, if you see over here, there are basically 3 time estimates. You've already seen that we are having the most likely time. This is the most likely time, right? This is your optimistic time, and this is the your pessimistic time. Okay, because definitely the optimistic time, it will be the least time of completion. So this is taking the least time, and is the probability of completing that, it will be the least. This is the probability. It will be having a minimum probability that everything is in your favor. You have studied 10 topics, and in GATE examination all the 10 topics is being asked. Not, probability is next to impossible. The next probability, you have studied 10 topics. You have studied 10 topics and you have studied 10 topics and all the 10 topics is not being asked. That probability is also very less. Okay, that is your pessimistic time. And on an average, the topics which are studied, most of the topics is being asked, but some of the topics is not being asked. So that is also the most likely, the maximum probability. Okay, so what we do, we try to calculate TE, that is TO plus 4 times TM plus TP divided by 6, and this probability will be slightly less than that of the most likely. This is your T, and the probability of completing that activity will be slightly less than that of the most likely. Is this clear? Understood? Now the next very important topic, because what you have done, you have calculated for individual activities the time of completion by using that relation, that is your TE is equal to TO plus 4TM plus TP by 6. Next problem that you are facing in mathematics is to calculate the standard deviation. Okay, to calculate the standard deviation. Now what is standard deviation? What is standard deviation? Right, the standard deviation basically denoted as sigma. Now what is standard deviation? Standard deviation basically means how much you are having a deviation from the mean value. How much deviation it is happening from the mean value, that is your standard deviation. Now if you see, let us suppose you have calculated, let's suppose this is the time of completion, that is TE for an individual for the project, that is capital TE, or let us say that is your for the activity, right? You need to calculate how much deviation it is happening. Okay, how much deviation it is happening. So what we do, we try to calculate standard deviation, that is equal to TP minus TO by 6. This is the standard deviation for individual activities. This is the standard deviation that is happening from it's the individual activity, that is TP minus TO by 6. Right? Okay. Fine. Now let us take an example. Let us take an example and we will be able to understand more clearly by using this example. On your screen you are seeing 7 activities. Okay, the first step is calculate the TE for the individual activities. So please, everyone will be helping me out to calculate this individual activity TE value for the individual activities. TE, what will be the value of TE for the individual activities? Quickly. And it's very easy because 99% of the time you will be getting a integer value. Okay, you will be getting a rarely a fraction value. 99% of the time you will be getting a integer value. So what's the formula for TE? TE will be equal to TP plus 4TM plus TO by 6. Right? So let's start with this one. So this is your TO, this is TO, this is TM, and this is TP. Right? So 1 plus 1 so 1 plus this will be 4 into TM. Okay, so 1 plus 4, 5 plus 7, 12 by 6, 2. Right? Clear? Next, 1 plus 16, 17 plus 7, 24, 24 by 6, that is 4. 2 plus 8, 2 plus 8, it will be 10. 10 plus 8 is 18, 18 by 6 is 3. 1 plus 4 plus 1, 6 by 6, 1. 2 plus 20, 22 plus 14, 36 by 6, that will be 6. 2 plus 20 plus 8, that will be 30, 30 by 6 is 5. And the last one is 3 plus 24, 27 plus 5, 42, 42 by 6 is 7. So this is the time of completion for the individual activities. Okay. This is the time of completion. Please cross check. 2, 4, 3, 1, 6, 5, 7. Are we getting the same values? Please, anyone who can help me out in this. If anyone is getting the different value, please do tell me in the comment section. Clear? Now, so what we have done, we have now calculated the estimated time for completing an activity by using this relation. The next step is draw the network diagram. Now, if you want to draw the network diagram, very basic. Always try to make your network diagram as simple as possible. So 1, 2, 2, 1, 2, 1, 3, okay, 1, 4, 2, 5, 3, 5, 4, 6 and 5, 6. Yeah. Done? Network diagram done. Can anyone tell me what is the critical path? Quickly, what is the critical path? Write in the comment section. Which events makes this your critical path? Let me write the time. This is 2. 1, 3 is 4. 1, 4 is 3. 2, 5 is 1. 3, 5 is 6. 4, 6 is 5. And 5, 6 is 7. So quickly, what is the critical path? Anyone in the comment section? Quickly, this type of question is being repeatedly asked in common link problem. 2 plus 2, 4 marks. Aram se you can score. 1, 3, 5, 6. 1, 3, 5, 6. Yeah, I think I'm getting some answers. ABM is giving, Bhargav is giving. 1, 3, 5, 6, I think, right? There is no 7 event. We are having till 6th event. So 0, this is 2, this is 4, this is 3, 3, 10, 10, 17. Yeah. So what is the critical path? 1, 3, 5 and 6. Perfect. This is the critical path. 1, 3, 5, 6. 1, 3, 5 and 6. Now tell me, what is this 17 signifies? This 17 signifies the time of completion of the project. So capital TE, that is equal to, let's say that is given in days. So 17 days is the time of completion of the, it is a minimum time to complete the project. So 17 days is nothing but the minimum time to complete the project, and the critical path is 1, 3, 5, 6. Is this clear? Right. Now, the next one is, let us suppose I need to calculate the standard deviation for the entire project. Previously, what we have studied the standard deviation only for the activities. This is for an activity. Okay. But if I want to calculate what is the standard deviation for the entire project, then what we do? We calculate the standard deviation for the critical activities only. Is this clear? Fine. And how to calculate for the entire project? The standard deviation for the entire project, or I can say for the critical path, that will be equal to under root of variance square. Summation of variance square. Variance square for the critical path only. Right? Exactly. Under root of the summation of the variance square only for the critical path. We should not be calculating for the non-critical path, because that will be wastage of time. Remember one thing, you just only need to calculate the standard deviation only of the critical path. Okay, what is variance? What is variance? Variance is nothing but the square of the standard deviation. Variance is nothing but the square of the standard deviation. Now let us come back to that table and let us calculate what was the critical path. Now if you see, we are having the critical activities 1, 3, 5, 6 and 1, 3, 3, 5 and 5, 6. We will be calculating the standard deviation on only these 3 activities. So standard deviation of these 3 activities. So what will be standard deviation? This is, what is the formula of standard deviation? That is equal to TP minus TO by 6. TP minus TO by 6. So this is your TP. 7 minus 1 by 6, that will be equal to 1. This one. 14 minus 2, that is 12 by 6, that is 2. 15 minus 3, 12 by 6, that is 2. So what we have got the standard deviation of these activities which are lying on the critical path. Is this clear? Fine. If you want, you can calculate for the non-critical path also, but that is not required. Try to calculate only for the critical path. Now, if you want to calculate for the entire project, standard deviation for the project, okay, that will be equal to under root of 1 square plus 2 square plus 2 square, because that is standard deviation. 1 square plus 2 square plus 2 square, that will be under root of 9, that is equal to 3. So the standard deviation for the project is nothing but 3 days. Okay, for the entire project, the standard deviation will be equal to 3 days. Is this clear? Always try to identify the critical path, calculate the standard deviation of the critical path activities. Okay. Fine. And please try to calculate the variance square. Yes. Yes. Anyone having a doubt? Yeah, Newton is having a doubt. Previous, which one? This one? Yeah, this one, right? I'll be coming back to this, right? Fine. Now, what we have calculated the standard deviation for the project. Okay, this is the standard deviation of the project. And what you have calculated, let us suppose we are having a beta distribution. Let us suppose this is your 17 days, that is estimated time of completion of the project, that is TE, already calculated. Let us suppose you want to calculate what is the probability what is the probability that this project will be completed in, let's say, 20 days. Yes, right? Let us suppose I need to calculate what is the probability of completing this project, because now I'll be dealing with project, because this TE is the for the entire project. This is the minimum time required to complete the project. Now let us suppose I need to calculate what is the probability of completing this project in 20 days. In 20 days, you need to calculate this probability. For that, what we do, because this is a beta distribution. Okay, this is a beta distribution, right? So you will be calculating a very important parameter that we call it as standard normal variate. Standard normal variate denoted as Z. Okay, right? Is this clear? Fine. You need to calculate the standard normal variate that is denoted as Z. We will be understanding the significance of standard deviation from this. Standard deviation simply signifies what is the deviation it is happening from the mean value. If I say from mathematical terms, what is the significance of standard deviation? That is how much deviation is happening from the mean value. That is your standard deviation. Now, TE is 17 days. Okay, this is your activity duration, that is time. So definitely your 20 days will be slightly on the right hand side. Here will be something around like 20 days. Okay, so this is the complete probability. Now how to calculate this mean value? How much deviation it is happening from the mean value? So we know that Z is equal to TS minus TE by sigma, or I can say TS is equal to TE plus Z into sigma. Okay, right? So I can say this value is nothing but Z into sigma. Is this clear? This value, how much variation it is happening from the standard deviation, okay, from the mean value, multiplied by the standard normal variate will be giving you the exact value. So from there, what we have calculated the value of Z. Now let us take back this example. In this example, what was happening? Your TE value you have calculated by the network diagram was 17 days. The TE value that you have calculated from the network diagram was 17 days, right? The standard deviation you have calculated is 3 days, right? Let us suppose you need to calculate the Z value. And what was the question? What is the probability of completing this project in 20 days? So your scheduled time will be 20 days. Okay. So what we do? We try to calculate the value of Z. We try to calculate the value of Z. Z is equal to TS minus TE by sigma. TS is equal to 20 days minus TE is equal to 17. Sigma is equal to 3. We'll be getting Z is equal to 1. Now, the Z is equal to 1. Z is equal to 1. What is the significance of that? For that, we'll be using a table. Okay, for calculating this Z is equal to 1, we'll be using this table. Okay, it is given for Z equal to 0, 0.5, Z equal to 0.1, 0.53, like this. So, at Z is equal to 1, it will be approximately equal to 0.836, something around this. Okay, 0.836. So, what is the significance of that? The probability of Z is equal to 1 is equal to 0.836, or I can say 83.6%. What is the meaning of this? The meaning of this is, if you want to complete this project whose minimum time was 17 days and you want to complete in 20 days, what is the probability of completing? The probability of completing this complete project is 83.4 days, or that is the 83.4%. Is this clear? Now, the problem that many student is facing, sir, how to remember this table? How to remember this table? It is not practically feasible. So there are some standard values that you should be knowing. There are some standard values that you should be knowing before solving any question. Okay, the standard values are, for Z is equal to 0, it is equal to 50%. For Z is equal to 1, it is 84.3 or 83.6, whichever if we come to 84.3% approximate value. Z is equal to 2 is equal to 98.1%, something around 98%. Okay. Apart from this, if they are asking any value, that you should they will be given in the value will be given in the problem. These are some standard value. Now sometimes what is happening, you will be getting, let's say Z is equal to -1. If you're getting Z is equal to -1, how to calculate? It is always a complementary function. Z is equal to -1. Okay, that will be equal to 1 minus probability of Z is equal to 1. Okay, so we know that what is the probability of Z equal to 1? That is equal to 84.3. So probability of Z is equal to -1. 1 minus 0.84, that will be something around 16.7% approximately. Is this clear? Fine. So complement, because definitely if you see from the graphical approach, those who are not able to understand, let us understand this graphical approach. Let us suppose this is Z is equal to 1. Okay. This is your Z is equal to 1, and you are getting this as the complete probability of 84.3%. Okay, this is for Z is equal to 1. If I want to calculate for Z equal to -1, your graph will be something like this. This is your Z is equal to -1. If I say Z is equal to 0, that will be exactly on the center line. Right? And the probability of Z is equal to 0 is equal to 50%. That is the significance of standard normal variate. Okay. Is this clear? 15.7. Yeah, 15.7. Approximately 16%. You can take it as 16%. Approximate 16%. Is this clear? Apart from this, 0, 1 and 2, if you are getting the value, they will be giving you in the problem. Is this clear? So let us come back to that problem because we'll be having a clarity in that question. Yeah. So question was something like this. Let us suppose, can anyone calculate what is the if I say TE is equal to 17 days, the same problem, and standard deviation that you are getting was 3 days. What is the probability? What is the probability of completing this project in 17 days? Quickly tell me in the comment section. What is the probability of completing this project in 17 days? Quickly. What is the probability of completing this project in 17 days? Very easy. That means this value is the schedule time, TS. TE you have calculated from the network diagram. This you have calculated from the table, from the network diagram for the critical path. So Z value calculate TS minus TE by sigma. Okay. So this is 17 minus 17 by 3, that is equal to 0, and probability of Z is equal to 0, that is equal to 50%. That means, what's the meaning of this? The meaning will be the probability of completing this project in 17 days, it's 50%. Is this clear? Fine. Exactly, Newton, because definitely you will be getting MSQ problem will be asked this year, because last year there was not a single problem from MSQ. So we can expect minimum 2 number of questions from the MSQ topic. Okay, from MSQ you can expect 2 questions. Is this clear? So for that you will be saying that you require some exact values. Yes, but my dear student, these are the standard values that you should be knowing. Okay, these are the standard values that you should be knowing, that I have showed you. 0, 1 and 2. Complementary will be 1 minus that value. Let's say if we want to calculate what is Z equal to minus 2, that will be approximately 2%. Okay, that means, can I say what is the probability of completing this project in let us say 11 days? What's the probability of completing this project in 11 days? Quickly. Exactly 17 days. I'm talking about the exact value, 17 days. What's the probability of completing this project in exactly 11 days? Okay, so this is your TS value. TS is equal to 11 days. Okay, TE already have calculated, that is 17. This is 6. So what is Z value? Z value will be equal to 11 minus 17 by 3, that is minus 6 by 3, that is minus 2. The probability will be approximately 2%, and that is quite feasible. Minimum time to complete this project was, taking that the same number of resources, was 17 days, and you want to complete by taking the same resources. Definitely it is not feasible. 2%, complementary function, because we know probability of Z is equal to 2, that is equal to 98%. So complementary of that will be minus 2 will be equal to 1 minus probability of Z is equal to 2, that is 1 minus 0.98, that is equal to 2%. Is this clear? Is this clear? Very basic. Fine. Very basic, and these type of question you can definitely expect in GATE examination. Many times I have seen that what they are asking common link problem. In the first part, they will be asking what is the time of completion of the project. You can easily calculate by using the network diagram, by using the critical path. Next, they will be asking what is the probability of completing the project in any scheduled time given in the problem. Okay, you can easily calculate. Is this clear? Fine. There is many times you will be getting values like this also. Let us suppose if Z is equal to 1.645, the probability is 95%. Okay, so usually it is not possible for any candidate to remember the entire table. Fine. That is why we are trying to remember only the standard values 0, 1 and 2, more than sufficient. Is this clear? Minimum what percentage we can consider feasible? It is exactly the probability, because probability is like what is the difference between crashing compared to this? We have not yet started the crashing. If I say we were having let's say 3 labor or 3 employees were there, and we were having 2 machines and 3 employees, and they are doing the project, and they were completing in 17 days. Okay, by using the same resources, what is the probability of completing the activity in let's say 11 days? That will be 2%. In crashing we are adding the resources. In this case we are not adding any resources. Is this clear, Sudarshan? Fine. In this case we are not adding any resources. This is by using the same number of resources. What is the probability of completing that project in this scheduled time? Is this clear? Crashing will be the next segment that will be starting right now. In crashing, what we are doing, we are increasing the resources. Now we'll be increasing the machine by, let us suppose, instead of 2 I'm using 8 machines. Instead of 3 supervisor I'm using plus 13 supervisors. That will be called as crashing. I'm increasing the resources. Is this clear? I'm increasing the resources, but here I'm not increasing any resources. By changing the resources, we are basically doing the crashing project or crashing an activity. Here we are not doing any crashing activity. Is this clear? Is this clear? Yeah. Definitely, that's why I'm saying, right? That is why I'm saying 11 days. So it is practically not feasible. That's why I'm getting a 2%. It should be always be greater than 17 only. If I say exactly 17 number of days, what is the probability? That is 50%. We can complete that project in that 17 days. We cannot complete. There's a 50-50 chances. Okay, there's a 50-50 chance because I'm not changing the resources. Clear? Chalo. Now let's do some crashing operation. Because crashing se bhi I've seen some of the questions not being asked regularly, but you can expect a question from this topic, because this makes the Pert CPM the topic to be slightly critical, or we'll say slightly complicated. But it's very easy. If I talk about the crashing operation, it's very easy. What do you mean by crashing? What do you mean by crashing? Crashing is basically you are decreasing the number of days by increasing the number of resources. Simple fundamental is you are increasing the resources and you are decreasing the time of completion of an activity, and by doing so you are decreasing the time of completion of the project, because by doing this we are decreasing the time of completion of an complete project. Okay, so the question that will be asked, sir, the cost should be increasing, because earlier we were using 10 machines, now we are using 20 machines, so definitely the cost should be increasing. Yes, absolutely clear. But here we will be dividing the cost into 2 segments. Okay, we'll be dividing the cost into 2 segments. One is the direct cost, and second is indirect cost. So can anyone tell me what do you mean by indirect cost and direct cost? Anyone in the comment section? What is the difference between a direct cost and an indirect cost? Quickly. What is the difference, major difference between a direct cost and an indirect cost? Because by having a clarity, the difference between direct cost and indirect cost, we can easily understand the crashing segment very clearly. Cost first decreases, then increases. Okay, can you tell me some examples of direct cost? What do you mean by direct cost? Direct cost is basically, it is that cost which is directly associated in completing the project completion. That means let us suppose the machinery, the rent of the machine. Okay, we can say the we can say resources, labor, daily labor, the cost of daily labor. Okay, that means if you are increasing the resources, your direct cost is gonna increase. If you increasing the resources, your direct cost will increase. Rent, electricity bill, because if you're increasing the machine, running of the machine is being increased. Earlier it was running for 8 hours, now you're running for 16 hours. So electricity bill is gonna rise. So direct cost is directly linked with the resources part. If you increase the resources, this part is gonna increase. Then what is indirect cost? Cost? Exactly, wages per of the worker per day. That is coming under the direct cost. If I talk about indirect cost, that is basically, let us suppose you are producing on Monday 100 units. On Tuesday you are producing let us suppose 50 units. So by doing so, are we decreasing the salary of the employees, or are we decreasing the salary of the security guard who was initially looking after the 100 units? Now he is looking for the 50 units. No, right? So these costs are basically those costs which is independent of the your production. It depends upon the number of days. Every day, like your stationary part, your security part, your safety part, the helmets, the worker that they're taking the helmets, that is being associated in the indirect. That means that's a daily basis. Okay, and it is independent. It is independent of the. It is independent of the we can say increase or decrease of resources, or I can say the production. Okay, fine. So I can say directly that the direct cost and indirect cost, the direct cost is directly involved with the completion of an activity. It includes a direct material, direct labor, cost of machine, equipment, etc. If I talk about indirect cost, that is the cost which is not directly involved in the execution of the completion of an activity, but yes, it is mandatory required for the safe and the timely completion of the project. Is this clear? It is mandatory. Let's say 100 rupees per day it is required. Okay, 100 rupees per day is required. So initially, let us suppose the time of completion was 17 days. Okay, and your indirect cost was, let us suppose, 100 rupees per day. So it was charging you total 1700 rupees. The total indirect cost is 1700 rupees. Now if you are crashing the activity, let us suppose by 2 days, now your indirect cost will be decreased. Okay, let us suppose now you are crashing and by 2 days and you are completing the activity, the project by 15 days. Okay, now the indirect cost will be 1500. Is this clear? So basically one cost is increasing, the direct cost is increasing by doing the crashing operation, and the indirect cost is decreasing. So we need to identify what is the optimum value where you will be getting that minimum cost and the time of completion will be optimum. Just like an break-even analysis. Just like break-even analysis you might have studied. Okay, or in inventory also you might have studied like this. One cost will be decreasing, the second cost will be increasing. So there will be a point where we'll be having that minimum cost. Is this clear? Fine. So if you increase the number of units is being increased, your direct cost is gonna increase, but indirect cost will gonna decrease, because if you are increasing the production rate, your target will be achieved much quickly. That means your indirect cost will be decreasing. No, overhead cost is basically coming under the direct cost. Crash cost is something different which is directly related with the direct cost. If you see here, if you see, let us take from a very basic example for having a clarity. There was an activity A and it was normally it was completing in normal time. It was taking, let us suppose, 10 days. Okay, it was taking 10 days, right? And the cost, the normal cost for completion of this activity was, let us suppose, 100 rupees. Okay, if you are completing this activity A, if you are completing this activity A in, let us suppose, 6 days, it gonna cost you, crash cost is equal to, let us suppose, 180 rupees. Okay, is this clear? That means activity A, if you are completing in 10 days, it will be costing you 100 rupees. If you increase the resources and if you try to complete this activity A in 6 days, it will be costing you 180. So can anyone tell me what is the per day crash cost, additional cost that we are giving? What will be the additional crash cost per day basis? So simply I can say the crash slope or crash cost slope, that will be equal to your cost, that is crash cost minus normal cost divided by normal time minus crash time. That is, what will be the value? That is 180 minus 100 divided by 10 minus 6. So it will be 80 by 4. 80 by 4, that is equal to 20 per day. That means additional you have to give 20 rupees per day if you are crashing for 1 day. That means, let us suppose it was completed in 10 days. It was taking 10 days. Now we want to complete this activity in 9 days. Then can you tell me what will be the total cost associated with this? If there's an activity A, which normally it is being taking 10 days, but you are completing this activity in 9 days, what will be the total cost associated with this? Can anyone tell me? The total cost will be 100 plus 20, that is 120. Is this clear? 120. That means additional you have to pay 20 rupees per day basis. Let us suppose I need to complete this activity in 7 days. Can you tell me what will be the total cost associated to complete this activity A? If you want to complete this activity to be completed in 7 days, so it will be equal to 100 plus how much days you are crashing? You are crashing 3 days. You are crashing, it was supposed to be completed in 10 days, but you are completing in 7 days. You are crashing this activity by 3 days. So 3 into 20, that is 160 rupees will be the total cost associated in completing this activity A in 7 days. Is this clear? Are you able to understand? And we can crash maximum up to 6 days. You cannot go beyond that. You cannot go beyond that. That is the threshold limit. Is this clear? That is the threshold limit in order to complete this activity. So by this way, you can calculate very easily this we call it as crash cost model. Okay, this operation that we have did, this is for a single activity. So we have to do the same exercise for the multiple activities, and we have to crash the entire project by some days that we have to calculate. So let us take an example. Okay, overhead cost will be considered like just like your we can say it is basically coming under your direct cost only. Is this clear? Like your total cost for we can say machinery cost, electricity bill cost, that is directly impacting our completion time, right? Overhead cost, if any cost, let's say X cost, it is impacting our time of completion of an activity, that cost will be considered under the direct cost. And if a cost, it is not directly impacting our time of completion, that will be considered under the indirect cost. Simple, very easy concept. Agar if any cost, it is changing the time of completion of the activity, that will be coming under the direct cost. If that cost is not impacting, that means if you are changing the cost, you are not able to change the time of completion, that will be considered under the indirect cost. Is this clear? Yes, definitely. And this crashing model can only be done in which one? Critical path only, because we know exactly what is the time of completion. This is, we can only proceed under the critical path method, that is deterministic approach. Pert analysis is a probabilistic approach, already we have discussed. Is this clear? Let us take one example so that we can have more clarity. And from this example, we'll be able to the question is very easy, but we try to have more understanding from this question. The question is something like this. The following table gives the data on the normal time, normal cost, crash time and crash cost for the project. Is this clear? What is the cost to reduce the project by 2 days? It's a very easy question. What is the cost in order to reduce this project by 2 days? That means it was taking some time. It was taking some X time. You have to decrease the time of completion. The time of completion of the entire project by 2 days. What additional cost you have to pay? That they are asking. So let us take this example. In this example, they are saying activity 1, 2, normal time is 8. Normal time is 8 days. Normal cost is 100 rupees. If you are crashing by 6 days, it will be costing you 200. Now, the first step is calculate the cost slope. Now, why we are calculating the cost slope? Now, if you go back to this, yeah, normally what we are assuming a linear decrement. If you see on the y-axis, we are having cost. On the x-axis, we are having time. Okay. So there is an activity. There is an activity, right? There is an activity. It is taking, let's say, normal time. This is a normal time, and the cost associated is this one. Okay, and let us suppose if you are crashing this, so definitely the time will be decreasing, the cost will be increasing. So let's say this is the point where we are having this. So this is a linear approximation we are doing. So this slope we are calculating. How to calculate this slope? The change in cost by the change in time. The same thing we have did by using an example. The same thing we have did this exercise. 10 days, 7 days, 6 days. Already we have did this exercise. So we are basically calculating the cost time slope. This is nothing but the slope. This one. If we calculate theta, that is slope, that is change in the y-axis divided by change in the x-axis. That is why we need to calculate the cost time slope for the entire activity. So now coming back to this problem, yeah, let us calculate the cost slope for the entire activities. I'll be telling you a simplest way. Okay, calculate. How to calculate? Tell me the first one. Tell me for the first activity 1, 2. What will be the cost slope? What will be the cost slope for the first activity? Quickly. Cost on the y-axis, on the numerator, time on the denominator. 200 minus 100 divided by 8 minus 6. So what will be the value? 100 by 2, 50. 100 by 2 is 50. This will be 200 by 2, 100. This will be 40 divided by 1, that is 40. This will be 300 divided by 5, 60. This is 100 divided by 4, 25. 20 divided by 2, 10. I hope so now this is clear. How we have calculated this value is very easy. You have to calculate the slope by using the crash cost minus the normal cost divided by, definitely the normal time will be higher. Normal time minus the crash time. So 200 minus 100, 100 divided by 2, 50, right? This is 200 divided by 200, right? This is 40 divided by 1, 40. This is 300 divided by 5, 60. This is 100 divided by 4, 25. And this is 20 divided by 2, that is 10. Is this clear? We have calculated the cost law. Now the next step is we need to draw the network diagram. Next step is draw the network diagram. Let us draw the network diagram. 1, 2. 1, 2, 1, 3, 2, 3, 1, 3, 2, 4, 2, 4, 3, 4, हाँ ठीक है, 2, 4, 3, 4, 2, 5, 2, 5 and 4, 5, something like this, right? So what is the time of completion? That is 8, 1, 3 is 4. We'll be writing the normal time, right? 2, 4 is 2, 2, 5 is 10, 3, 4 is 5 and 4, 5 is 3. So quickly tell me what is a critical path. Rohan has already calculated 1, 2, 5 is a critical path. Okay, perfect. Let's cross verify. Is Rohan correct or not? 0, 0, 8, 0 plus 4 is 4, right? 8 plus 10 is 18. This is 10. This is 9, 13, 18. So your critical path is 1, 2 and 5. So 1, 2, 5 is the critical path. 1, 2, 5 is the critical path, right? 1, 2, 5 is the critical path. Very easy. 1, 2, 5 is the critical path. Next, and what's the time of completion? 18 days is the time of completion. 18 days is the time of completion. That means capital TE is equal to 18 days, right? Okay, the next step is, the question is you need to complete the activity. You have to decrease the time of completion by 2 days. According to the question is, what is the cost to reduce the project by 2 days? Okay, now you will be only seeing the activities which are on the critical path, because that will be deciding the time of completion. So 1, 2 and 2, 5. These two are the critical activities. 1, 2 and 2, 5 are the critical activities. And let us check what is the per day cost or crash cost they are taking. So it is taking 50 rupees per day and it is taking 60 rupees per day. So tell me which activity you will be crashing. Which activity you will be crashing? Very easy. You need to crash by 2 days. So if you crash activity 1, 2 by 2 days, it will be costing you 100 rupees. 50 into 2. If you crash activity 2, 5 for 2 days, it will be costing you 120 rupees. So definitely you will be crashing the activity 1, 2 by 2 days. But very important, you always need to cross check. You always need to cross check. Sir, by crashing, is my critical path changing or not? That we need to cross verify. Is this clear? That we need to cross verify, because if by anyhow, if your critical path is being changed, then you have to look after that. Okay, let us do one thing. If you crash, now definitely you will be taking activity 1, 2 because it is cheaper. It is saving 10 rupees for 1 day. If you are crashing for 2 days, you'll be saving 20 rupees, right? 50 rupees per day, 60 rupees per day, right? So let us check. If you crash this activity by 2 days, is my critical path changing or not? 1, 2. If you are crashing this activity 1, 2 by 2 days, is my critical path changing or not? Please cross check. That will be 6. Okay, this will be 6. 6 plus 10 is 16, right? 6 plus 2, 8. 8 plus 3, 11. Our critical path is not changing. Our critical path is not changing. That means our final answer will be yes. Now we can proceed. We will be going ahead with activity 1, 2 crashing for 2 days because our critical path is not changing. That means our time of completion has been now changed to 16 days. Okay. Yes, definitely, Pradyum. Look. There are two activities. Activity A, it is taking 50 rupees for 1 day to crash. This activity B, which is taking 60 rupees per day. So we're having two options. Okay, we're having two options. One is 50 rupees per day, second is 60 rupees per day. So which one you will be preferring? And both you can easily crash for 2 days. So definitely I'll be taking that activity which is having the minimum cost for 1 day crash. Okay, and that too which is lying on the critical path. Okay, fine. That too which is lying on the critical path. If you crash this activity 1-2 by 2 days, it will be costing me additional 100 rupees. Additional 100 rupees it will be costing, right? Fine. Is this clear? If you crash this by 2 days, it will be taking 120 rupees. So definitely, why I'll be taking? I can save at least 20 rupees. In a 1 crore project, I can save 20 rupees and I can take a promotion by saving 20 rupees, right? Okay, is this clear? So definitely I'll be taking on the critical path which is having the minimum cost low. So these two activities were on the critical path. So among these two, this is the activity which is having the minimum cost low. But make sure you need to cross check one very important thing. If by any chance there's a probability, let us suppose by crashing this activity 1-2 by 1 day, what has happened? Your critical path has changed. So in that case, you need to identify the multiple crashing should be done. Let us take a very basic example. Let us suppose I'm having 1, 2, 3. Let us say this is 4 and this is 5. Right? Let us take an example. This is activity A taking 6 days, activity B taking 3 days, activity C taking 5 days, activity D taking 9, and activity E taking 8 days, 7, 6 or 5, 4, 2, and activity F as 7 days. Tell me, which is the critical path? Which is the critical path? Quickly. Which one is the critical path? We are having 3 activities, A, B, C, D and E, F. 3 pathways is given. So which one is the critical path? It's a random question. It's a random question. Which one is the critical path? Sir, all the 3 are critical path. All the 3 are critical path. Your AB is a critical path which is having a time duration of 9 days. Your CD is also having a time duration of 9 days. Your EF is also a critical path, 9 days. Okay, all 3 are critical paths. Entire network is a critical path. Now, let us suppose they have given for A, B, C, D, E and F. Let us suppose their crash cost delta C by delta T for A activity is 10, B is let us suppose 5, C is 5, D is 10, E is 5 and D is something like this. Okay, something like this is given at random value. This is the cost slope per day crash cost, right? I need to crash this project because it is taking 9 days for completion. I need to complete this activity in 8 days. So tell me how much additional cost I need to bear. How much additional cost I need to bear? I need to complete this project in 8 days. Can anyone tell me? Very basic. Very basic. Then after that I'll be going for the float. Then we'll be going for the break-even analysis. It will be taking hardly 20 minutes. Okay. So all the critical path, all are critical path, right? So we will be taking those which are having the minimum. Okay. Simple. So in AB, let us take A and B. So this is one set of critical path. This is one set of critical path. This is one set of critical path. So between A and B, which activity shall I need to take? Which activity shall I need to take? And how many activities I need to crash? 1, 2 or 3? how many activity I need to crash. Let us say some students saying, sir, I will be crashing only one activity. Let us suppose I'm crashing activity B by 1 day. I'm crashing activity B by 1 day. Perfect. Crashing this activity by 1 day. So 6 plus 2, 8. So is my activity completion time 8? Yes or no? I'm only crashing activity B. Is my project completion time is 8? No, sir. It won't be 8 because now we are having two critical paths. This one and this one. This is 5 plus 4, 9. 2 plus 7, 9. Not possible. Not possible. Sir, you cannot alone crash this one. I need to crash in every pathway 1 activities. In every pathway, I need to crash 1 activity. So I need to be crashing B activity in AB. Now in CD, which activity will be taking? I'll be taking activity C because it is taking minimum. So activity C will be crashed by 1 day. This will be 4, right? This will be 4. Okay. Next, in activity EF, I'll be crashing activity E. So this will be crashed by 1 day. So now you are having an updated as 6 plus 2, 8. 4 plus 4, 8, 1 plus 7, 8. Now your 8 is being completed. So you are crashing activity B, activity C, and activity E will be crashed. Okay. And what is the additional cost that you need to bear? Additional cost. You are crashing for 1 day. So you'll be having 5 plus 5 plus 5. 5 plus 5 plus 5, 15. 15 rupees you have to pay additionally in order to crash this activity or this project for 1 day. Is this clear? Is this clear now? Understood? Very basic example. At random example. Bilkul at random. Understood how to proceed, and definitely gate में इस level के questions ही आएंगे. You will be getting these type of questions only. Okay. Crashing में ये won't be it. This is not any ESE mains problem that will be getting a lengthy problem. No, we'll be asking you technical conceptual based problem. That's it. Okay. So don't worry. Is this clear? Chalo. Now let's proceed. The next pattern of question that they gonna ask from Pert CPM, that is the last one, float and independent float, your this one free float and your total. Okay. Chalo. Now what do you mean by float or slack? Many of the students will be saying, sir, float or slack. Basically both are same. Okay, one is defined in a Pert analysis, second is defined for CPM. That's it. Basic meaning is same. The float basically means, let us take this same example. Let us take this example. Yeah. Now, let us take this example. It is taking 18 days for the completion. Okay, it is taking 18 days. So let us suppose if I want to increase the time of completion of activity, this one, 1-3 by 1 day. So can we increase the time duration without changing the time of completion? Are you able to get the problem? Question is 18 days is the time of completion of the project. I am increasing the time of completion of activity 1-3 by 1 day. So does that gonna change my critical path? Does that gonna change my the time of completion? Sir, no. If you change this 4 to 5, no problem, sir. Still 5 plus 5, 10, 10 plus 3, 13. Still our time of completion will be 18. Sir, I'm changing to 6. 6 plus 5, 11, 11 plus 3, 14, no problem. I'm changing to 7. अरे भाई बहुत हो गया. 7 plus 5, that is 12. Sorry, 7 plus 5 is 12, 12 plus 3 is 15. No problem. अरे कितना बढ़ेगा? How much you will be increasing? So you can increase up to a limit such that your critical path gonna change. So this is your total float. That means on activity 1-3, if you increase or decrease, that not gonna change my time of completion. That means there are some additional resources that we are having. So if, and that is the meaning of float. Okay, that is the meaning of float. Float basically means if an activity, if its float is having a positive value, right, if it is having a positive value, that means there is some surplus amount of resources kept on that particular activity. So if you want, you can take some resources and you can shift to any other activity if you want to crash the activity. That means, let us suppose there were 2 machines over here, okay, and it was taking 4 days and there was only 1 machine. So what we do, let us suppose I need to crash this activity, because critical path activities can only be crashed. So I can take 1 machine, keep it over here, and instead of 4 it is taking 8 days. No problem, sir. No problem. 8 plus 5, 13 plus 3, 16. Still our time of completion is not being changed, and further it is helping us to reallocate our resources. Right? It is helping us to reallocate the resources by not changing, or if you want to change the activity time, it can be decreased also. It cannot be increased. Okay, so for non-critical activities, your float value will always be a positive value. For critical activities, it will always be equal to 0. Is this clear? So direct cost decrease in crashing. No, Ayush, direct cost increases. Already have discussed this question. This question only. In this case, this all cost that is being stated, this is nothing but the direct cost only. Okay, let's suppose there is an indirect cost which is given 20 rupees per day. Okay, 20 rupees per day. So earlier it was taking 18 days. So 18 into 20 was a total indirect cost. You have crashed this activity by 2 days. Now the updated time is 16. So 16 into 20 will be your new indirect cost, total indirect cost. Okay, so whenever you are crashing, your direct cost will always gonna increase, indirect cost is gonna decrease. Is this clear? Now coming back to this, बहुत basic है. Now many students are having doubt or difficulty in order to calculate total float, independent float, free float. Arey bhai, there's a very simple method. There's a very simple method. Let us take one random example. 1, 2, 3, 4, let us say this is 5, something like this. I'm taking random values. Please tell me what will be the critical path. Let us say this is 3, 5, 7, 2, 4, 10, and this is 8. Tell me what is the critical path quickly. What will be the critical path quickly? We'll be understanding this by using the same diagram, the total float, free float and independent float. So let us calculate. What we do, we try to go from 0. 0 plus 3 is 3, 3 plus 5 is 8, this is 0 plus 7 is 7, 7 plus 2 is 9, so this will be 9, the highest value. So this is, we call it as forward computation. This we call it as forward computation. When we go in the forward direction, we always try to go for the highest value, maximum of all, because if you go from this pathway, it was 3 plus 5, 8. From this pathway, 7 plus 2 is 9, so I'll be taking the highest value. So this is 4 plus 10, 14, 9 plus this will be 17. So what is the critical path? So your critical path will be 1, 3, 5 and 6. This is the critical path. Okay, this we call it as forward computation. Now we go for the backward computation. Backward computation means very basic. Look, this is starting from 17. Now 17 minus 7. What is 17 minus 7? That is 17 minus 10. That is 7. Only one pathway to reach over here. Now 17 minus 8. That is 9. 9 minus 5. That will be equal to 4. 9 minus 2, that is 7. 4 minus 3 is 1. 7 minus 7 is 0. 7 minus 4 is 3. So in the reversed back direction, this we call it as backward computation method. In that we take the value, the minimum value. Okay, so we are having three possibilities, either 1, 0 and 3. We'll be taking the minimum value, that is 0. So this is the values. Okay, so if I say this is an activity A, if I say this is from event 1 to 2, this is activity A and the time of completion is Tij, right? So for every activity we'll be having the earliest start time, the earliest finish time, the latest start time and latest finish time. For every activity, if you see 0, 0, 3, 4, 9, 9, 7, 7, 4, 7, 17, 17. For every activity we have calculated. Okay, now what is total float? Simple method, बहुत basic. Total float is equal to, never ever will be having any confusion, the cross difference, the subtrend Lj minus Ei minus Tij. Lj minus Ei minus Tij. You can calculate the total float by using this formulation, very basic. Now let us calculate for activity 2.5. Let us take activity 2.5. Okay, what are the values? 3, 4, 9 and 9. And what's the Tij? That is 5. So can you tell me what is the total float? What is the total float? Total float will be equal to 9 minus 3 minus 5. What's the value? It is equal to 1, right? 6 minus 5, 1. That means if you are increasing this value by 1 day, if you are changing this activity from 5 to 6, then your critical path gonna change. That means you can only increase the activity 2.5 by 1 day such that you are not changing the time of completion, that is 17. You can cross check. If you are changing from 5 to 6, 3 plus 6 is 9, 9 plus 8 is 17. Still it will be 17 days. That means you can increase the activity time of duration by activity of 2.5 by 1 day. Your time of completion is not changing. Is this clear? Fine. Simple way. Let us suppose I am calculating for 3.5. 3.5. 3.5. 7, 7, 9, 9 and time of completion is 2. Chaliye, what is the total float? What's the total float? What is the total float? That is equal to 9 minus 7 minus 2, 0. 9 minus 7 minus 2, 0. Why it is having 0? Because sir, it is on the critical path and we cannot have any additional resources, because what does it mean by the float? Float directly means if you are having a positive float, that means you are having surplus of resources. You are having surplus of resources. If you are having float to be 0, that means you are having adequate float, adequate resources. Adequate resources. That is, you are not having surplus, you are not having insufficient. Okay. If you are having a negative float, you are having float to be negative, that means you are having shortage of resources. Is this clear? You are having shortage of resources. Understood? So definitely we know that critical activities cannot have a float because it cannot be having a surplus. It is having adequate resources. So that is why if you cross check for any critical path activities, it will always be 0. You can cross check. Is this clear? Done. Next is free float. Free float is basically the early start. That means the amount by which an activity can be delayed without affecting the early start time of the succeeding activity. That means free float is equal to Ej minus Ei minus Tij. Let us take the example. This one. I'm taking the same example. Free float. 9 minus 3. 9 minus 3 minus 5, that is equal to 1. That means I can change the time of completion without changing the time of the succeeding activity. Without changing the time of completion of the succeeding activity, I can change. That means if you change this by 6, 3 plus 6 is 9. You are not changing the early start time of the succeeding activity. This is your succeeding event. Is this clear? Okay. The last one is the independent float. It's just the reverse. I can say its amount by which an activity can be delayed without all the preceding activities are completed as late as possible. Okay. That means independent float is equal to Lj minus Li minus Tij or Dij, whichever you're feeling comfortable. Take the same example. Yeah. Independent float. 9 minus 4. 9 minus 4 minus 5. That is equal to 0. That means if you are increasing this activity or decreasing the activity, your preceding activity will definitely gonna change, because we are not having any float, independent float for the preceding activity. That means if you are changing this from let us suppose 5 to 6, let us suppose, so 9 minus 6 is 3, which is not feasible. Is this clear? Understood? So very basic, you just have to understand by using the simple direct formulation. Total float is equal to Lj minus Ei minus Tij. Which one? Total float. Lj minus Ei minus Tij or Dij, whichever you're feeling comfortable. This is the actual completion time. Free float is equal to the early start time calculation, Ej minus Ei minus Tij. If I talk about independent float, that is based on the latest start time, Lj minus Li minus Tij. So by using this, you can calculate independent float, free float of any activity, and you should not be having any confusion. Always try to calculate the floats by using this method. There are many formulas in the market. Many students do message me, sir, can we use this formula? Don't go for that, because you will be having confusion. This is a direct formulation to calculate free float, independent float or total float. Independent float, yeah, this one. This is basically we are calculating the latest, how much late we can start an activity. Independent float is basically how much late we can start an activity. That is the independent float. Free float is basically how much delay we can do for the succeeding activity can be completed. Okay. If I say free float, the amount by which an activity can be delayed without affecting the succeeding activity early start time. If I talk about independent float, is the amount by which an activity can be delayed when all the preceding activities are completed as late as possible. That means how much delay we can do for the previous activity. This is independent float. Okay. For free float, that is basically for the next activity, the succeeding activity. Is this clear? Anyone having any doubt? You can calculate by using this formulation, very basic. That means I can say free float Ej minus Ei minus Tij, independent float Lj minus Li minus Tij. All the different formulas right on a single screen. Clear? So this completes our Pert CPM. Very important. We have given majority of the time to this particular segment. So let us start with the second topic, that is break-even analysis, because now we have to pace up a bit, because I was expecting 1.5 hours for that, but I think I have given slightly more time to that topic. Okay, no worries. At least you have understood that topic and you can solve all the questions from that topic. Okay, that is why I given Pert CPM the most important topic from GATE point of view. Okay, next one is very basic, break-even analysis. What is break-even analysis? It is basically it's a no profit no loss condition. Okay, whenever you are doing a production, whenever you are producing any product, right? So what we do, on the instant you are doing the production, are we getting the profit? We are not getting the profit. We always get a profit after some point of time, after some production, we are getting the profit. So what is that unit of production that we need to do? Let us suppose I'm having, let us say there's a industry, and you are producing only one unit per day. Okay, and you are getting a profit of rupees 10 if you are selling one unit, but you are giving, let us suppose, 100 rupees per unit. It is being given for every day. So we are having a net loss. We are having a net loss, right? So what we do, we try to increase the production rate so that our profit can be achieved, because every industry will be doing the production only to have a profit. Never ever any production, let's say any company, let's say Tata Motors or HUL or ITC, these companies always they try to get a profit. Okay, no company is planning or doing the production in order to get a loss. They always need to get a profit. So this break-even analysis will be helping us to identify what is the threshold value that we need to do the production in order to get the profit. Threshold value means कि इतना तो बनाना ही पड़ेगा to get the profit, right? Okay, so let us understand this break-even analysis in a very quick manner. So this is a condition where we are having a no profit, no loss condition, which a production manager need to keep in mind. Because let us suppose, in order to get a no profit, no loss, you need to get 100 units production every day. If you are doing 100 unit production, you are getting a no profit, no loss. So that production manager, he needs to analyze, he needs to keep, always need to have a track on this, that he is doing a minimum production of 150 units, so that it is not reaching this threshold value. So the production manager is always keeps a track what should be the production rate. If we are decreasing and we are approaching towards this break-even point, then some additional tasks need to be done in order to have no loss condition. Okay, right? In order to reduce the loss condition, we need to go for some additional methods need to be done. So this is a very important tool which a production manager is using in order to track the profit or loss condition. Okay, now how to identify? How to identify? Now in this case, the total cost. The total cost is basically comprises of two costs. That one is your fixed cost, and second is the variable cost. Second is the variable cost. Okay, now what is fixed cost? What is variable cost? Fixed cost is basically, these are the costs which is independent of the number of units. Let's say machine, the rent of the machine. The rent of the machine, if you are producing 100 units a day, you are producing 2 units a day, it will be charging 10,000 rupees per month, because that is a fixed price. It is not, it is independent on the number of units produced. So the cost which is associated, which is independent with the number of units produced, that cost we call it as a fixed cost, right? So this we call it as a fixed cost, right? Variable cost is basically like electricity bill. If you are increasing the number of or production rate, your cost is gonna rise. Okay, so if you are decreasing the production rate, your cost is gonna decrease. So that cost which is directly impacted by the number of units production, that we call it as the variable cost. So total cost will be equal to the summation of fixed cost plus variable cost. And we know that variable cost is per unit basis. So I can say small v is the variable cost per unit. Okay, fine. So if I want, if I say x is the number of units, x is number of units, so I can say capital V is equal to small v into x. Okay, so I can write the total cost to be capital F plus small v into x. So if I plot this on a graph, so I'll be getting the total cost to be something like this. This is the fixed cost which is independent on the number of units. This is X. This is your total cost. So this will be your variable cost, a linear line. Okay. So if you have, let's say this is the variable cost, that is V into X, and this is the fixed cost, that is F. Okay. So fixed cost basically comprises of these rent, rates, research and development, marketing costs, okay, administration cost, which is independent of the number of units. Okay. Variable cost is basically your daily wages, raw materials, right? We can have fuel wages. We can have some costs related to where number of units is being directly associated. Okay, this we call it as variable cost. So if you add these two costs, that will be the total cost. Okay, the next one that we call it as revenue. What is revenue? What is revenue? Revenue or sales. Revenue or sales, which is basically denoted as capital S. That means your let us suppose you are the owner of a biscuit company. You're a owner of a biscuit manufacturing unit. Okay, and it is taking 7 rupees in order to make 1 packet of biscuit. Okay, so definitely in order to get profit, what should be the price of selling? Definitely it will be higher than that of 7 rupees. Let us suppose you are selling at 10 rupees. So you are getting a potential profit of 3 rupees. Okay, you are getting a potential profit of 3 rupees, right? So I can say if S is the sale price or selling price per unit, so what is the total revenue? Capital S is equal to S into X. Okay, so if I say P is, I'm assuming P as the profit. If I assuming P as the profit, so can I say the total sale will be equal to the total cost plus profit? Yes, because I was taking 7 rupees, total 7 rupees was there for making 1 packet of biscuit, and you are selling at rupees 10 rupees. So what is the potential profit? 3 rupees. Okay, so if I want to have a condition that your no profit no loss condition, if I want to have a no profit no loss condition, that means the profit equal to 0, what should be the minimum? The selling price is same. Okay, the selling price is same. What should be the number of units need to be produced? So that will be called as a break even point. So break even point, also called as BEP. So this is a point we are having no profit, no loss. No profit, no loss condition, right? No profit, no loss condition. So here we can say the total sale is equal to total cost because profit is equal to 0. So small s into x plus f plus v into x. So x is equal to f divided by s minus v. So this x, that is the unit of production, this is that unit of production that you need to have minimum to get a no profit no loss, that is your break even point. So if you understand with the graphical perspective, if you see from the graphical, this is the cost and this is the units x. Okay, so first of all let us draw the total cost. That will be your fixed cost. This is the variable cost, right? And if you going for, because definitely your sales value, what is capital S, small s into x, right? So it will be something like this. Okay, so this point where we are having no profit no loss condition, this is the break even point. This is the break even point, and this is x BEP. That means this much amount of production should be done, minimum this much of production should be done in order to get a no profit no loss condition, and this point we call it as the break even point. Okay, fine. And this additional cost we call it as the your sale cost equal to the total cost, because here at this point your selling price or the total revenue will be equal to the total cost, because this is a no profit no loss condition. Okay, fine. So we always need to make sure that your production rate is always higher than this break even point. Because if you are having a production less than that of this, so you'll be always be getting a loss condition. Okay, so in order to get a always profit condition, we always try to have a production greater than that of this. So we take a margin of safety. We take a margin of safety, right? So let us suppose I'm taking a margin of safety over here. This is your X margin of safety. So this corresponding cost that you will be getting will be, this is the margin of safety, margin of safety. Okay, we always take a margin of safety from the BEP because we never ever design the production plant according to this value. Let us suppose X BEP is 80 units. 80 units is that point where you are no profit no loss condition. So you always try to design your production system in such a way that it will be, let us suppose 150 units is the threshold value, because you are not reaching this 80 value. So your margin of safety, let us suppose this is 150 and this is 80. So margin of safety will be equal to 70 units will be the margin of safety in order to stay away from that break-even point. Is this clear? So that production manager always keeps a track that your you are not falling beyond or below this margin of safety. If your production rate is in between this, then the production manager what will be doing? He will be changing some method, he'll be increasing some resources, he'll be doing some any XYZ activities in order to increase the production rate. Is this clear? Understood? So this is your margin of safety in terms of number of units. We can have margin of safety in terms of the sales point of view, right? Yeah. Margin of safety, sales point of view. So this is a sale value at any X minus the sales value at BEP. So this difference is the margin of safety sales point of view. If I want to calculate the margin of safety in units point of view, that is equal to X minus X BEP. I hope so now you have understood. I hope so now you understood simply by plotting the graph. This is your S, this is the total cost, this is BEP, right? Okay, let us suppose this is a point X units, this is the margin of safety in units. Corresponding to this, what is the total cost associated? This is the margin of safety sales point of view. Okay, not a difficult topic, it's a very basic topic, so we'll be going very quickly in this topic. Okay, now many students are having a doubt from this topic, that is profit volume graph. Have you everyone heard about this profit volume graph? What is the importance of this profit volume graph? Anyone? What is the importance of this profit volume graph? Why we are using this PV curve or PV graph? Anyone? We are using this PV graph where we are having a company dealing with multiple products. Let us take an example. Yeah, this is a Nestle company. It is dealing with multiple products like Kit Kat, Maggi, ketchup, coffee. You're having milk, Milkmaid, Kit Kat, Munch. So it is dealing with multiple products. So whenever you need to track the profit to volume ratio for multiple products, so there we are using this profit volume graph. We call it as PV, P by V, PV graph. Okay, for one product will be having one, for PV for second product will be plotting, PV for third product will be plotting. So by looking after only this PV curve, we can track on which product is going in the profit oriented and which product is going on a loss oriented. Okay, if in a same company we are having multiple products, like in this, okay, Nestle, we are having multiple products. On the screen you are having like 7 to 8 products. So if you want to track on a single graph which product is giving you more profit and which product is giving you less profit, you can have a track on this. So this PV curve or PV profit volume graph, it is basically used in a multi-product organization where the organization deals with a multi-product. Okay, and what is this PV value or PV curve? That is equal to contribution margin by the sales volume. What is contribution margin? Very basic. Yeah, okay. Now, if you see in this particular, this is for a single product. So in a single product, if you see this line, this is the profit volume line. So this is the break even, because if you are going less than this, then you always will be having a loss. And what will be that loss? That will be the fixed price. This point to this point will be the fixed price. Okay, because if you see, this is the total selling, this is the variable cost. Let us suppose I am not doing any production. So what's the total cost associated with that? What's the total cost? This is the total cost, and that is a fixed cost. Okay, and what is the selling point? That is 0. So if you are going for a 0 production, the total cost, the total loss that will be having, that will be the fixed cost. That is the same thing. When you are having 0 production, the total loss will be nothing but the fixed point. So when you go increasing, there will be a point when the loss and profit will be 0, and this point is break-even point. Is this clear? This point is break-even point. Now, anyone who can tell me what is your contribution margin? What is contribution margin? Quickly. Contribution margin. We know that sales is equal to fixed cost plus variable cost plus profit, right? So I can say fixed cost plus profit is equal to sales value minus variable cost, and that is equal to the contribution margin. Is this clear? Fine. So the difference between the selling price minus the variable cost, or the summation of fixed cost and the profit, that shows the value of contribution margin. Is this clear? Fine. So if you know this value, you can cross check. Let us suppose you are having multiple products like this. This is for product 1, this is for product 2, okay, and this is for product 3, right? So we can directly say, we can directly identify which product is more profitable. Okay, so or let me take the graph. You guys will be telling me this is one curve and this is a second curve. This is 1, this is 2. Which is more profitable? Product 1 or product 2? Which is more profitable? Product 1 or product 2? These are the PV graph or profit volume graph for product 1 and product 2. So definitely if you see, we are getting a break-even point at this point. After that, we are getting a profit. We are getting a break-even point at this point after having a large number of productions. So definitely one is more profitable over the 2. So if the slope is higher, if the slope is higher of this curve, so definitely that product will be having more profit. Simple way, very simple way. If the slope of profit volume graph is more, that directly implies that that is more profitable over the other, and that is basically we need to identify for a multi-product. Is this clear? Understood? Very basic. Perfect. Very good. Chaliye. Now let's start the very important topic, that is inventory. I told you we will be having this topic, break even, quick revision, because that is rarely being asked, and if they are asking 99% of the students, they're gonna answer very easily. Okay, but this topic is very important, inventory. Chaliye, what do you mean by inventory? By simplest way possible, it is nothing but stock in hand. We call the inventory to be nothing but the stock in hand. Okay, right? But is it good to have a stock in hand? Is it good? Like we are owner of a jewelry shop. Okay, you're having a diamond necklace, like you can have a jewelry shop and you are procuring diamonds in large number. So is that good for us? Because definitely if you are procuring a diamond in a large number, the cost associated in procuring will be very large, and definitely you're not gonna store the diamond in a box or just like in a small chamber. You will be having a security guard, a high tight security, CCTV will be there, right? So definitely there is a high amount of holding cost associated with that kind of inventory. Yes, okay, fine. So it is always mandatory to have an optimum number of inventory. Why? Because I'm saying, let us suppose I'm having a low inventory. Okay, let us suppose I'm having a low inventory. If there is low inventory, there's a possibility of stock out or shortage. If there's a possibility of shortage, the person who was coming to your shop to buy a product, you're not having a raw material, then how you can supply the final product? So that is not a good gesture, because there are two shops. One shop is able to provide the products anytime when a customer is going, and the second shop, it is always out of stock, it is not able to provide. So definitely every time a new customer is coming, every time that customer is going, it will be going to that shop where there is no stock out or very less number of stock out. So we have to go for an optimum number of inventory. Too much inventory, not good, because that will increase the holding cost. Less number of inventory, that is also not suitable, because that will decrease decrease the profit that could have got by having that raw material. So always you need to have an optimum level of inventory. Optimum level of inventory. So in this entire inventory topic, we will be calculating this optimum level. That's it. Okay. Fine. Exactly. If you if you're planning to buy a Rolls Royce, okay, so it's not like you go to a shop, you'll be getting a Rolls Royce, or you go to a shop, you'll be getting a Audi A6. No, you go to a dealer shop, they will be booking on your name, you'll be getting after 1 or 2 months. Okay, right? So it depends upon many factors. You cannot stock the inventory for a longer duration. You cannot have a shorter inventory, because that will directly impact the customer relationship, right? So we always need to have an optimum level of inventory. So in this particular topic, we will be calculating how to get an optimum inventory and what are the different costs associated with the inventory topic. So let's start this inventory topic. So in inventory, we are basically comprises of 4 different costs. Very important, guys. I told you 6 topics, which is very important. Among these 6 topics, the 3 favorite topics, okay, 3 favorite topics are like Pert CPM, inventory, and linear programming. These 3 are the favorite topics that you can expect in the examination point of view. Okay, so one important topic already covered. Second important topic, just now we have started. Third important topic, that is LPP, that will be studied in the tomorrow session. So let's start this one. Inventory is basically comprises of 4 costs: purchase cost, ordering or setup cost, holding cost, or carrying cost, or shortage cost. Normally in GATE examination, what I have seen that in last 15 years, they are more sort of going near about to that EOQ model, Wilson-Harris model, or the production model. Okay, fine. So we'll be giving maximum time to those models, because that is very important from GATE examination point of view. Now, what is purchase cost? You are purchasing this pen. There will be a cost, a unit price. Okay, so that is your purchase cost. Let us suppose your annual demand of this pen is 1000 units. Okay, and the unit price is 10 rupees per unit. So what will be the purchase cost? The purchase cost will be equal to 10 into that annual. That means I can say the annual demand into unit price will be your purchase cost. And how much cost it is being associated in purchasing this pen? It is not only this. Let us suppose you are purchasing in an Amazon website. Sometimes you are having an additional cost as delivery charges. If you have seen, if you are a non-prime member, they are usually charging the delivery cost, and sometimes for the prime members also they are charging a delivery cost, right? So that delivery cost, what is that? Do I need to consider under the purchase cost? No, that is not under the purchase cost. That is under the ordering cost. That is the cost associated in ordering that pen. Very basic example. A best example I need to say, IRCTC. You are all doing railway reservation online. है ना? You all are doing, you are going to the vacations to your home, you are going to your friend's place to party or anything. They are charging some additional cost like bank convenience fees. If you have seen, right? So that bank convenience fees is basically coming under the ordering cost, right? That means the cost associated apart from the unit price. I'm giving 10 rupees for this particular pen. For this particular pen, I'm giving 10 rupees. In order to bring this pen to my warehouse, what is the cost associated, like transportation cost, insurance cost, in between there will be some challans, like police gonna stop your truck, so you need to have that price. So all the cost, the miscellaneous cost that is associated in bringing that material to your warehouse, that cost is, we call it as ordering cost. Now sometimes we are having setup cost also. What is setup cost? Instead of purchasing the inventory, what we do, we try to produce or manufacture that your inventory. Example बताते हैं. Automobile industry. In almost 100%, I would rather say 100% of the industries are procuring tires from the other vendors, like MRF tire, Continental tires. There are many tires that you are seeing in the market. Okay, so what they are doing, they are directly procuring, they are not manufacturing the tires. Okay, if you say Maruti Suzuki or Tata Motors or any you take any firm, you name any firm, they are always trying to procure the tires. But let us suppose this year Hyundai has planned, let's try to manufacture the tires in-house and reduce that ordering cost. Definitely they're gonna have some costs associated in procuring that material. Tire you are procuring, they will be having some cost. So what we have done, we are now producing or manufacturing that inventory in-house. So the cost associated in manufacturing, definitely it won't be free. You need to have machines, you need to have raw materials for that. So wo sab will be coming under the setup cost. Okay, second one, holding cost or carrying cost. What is holding cost? By the name itself, already we have seen the cost associated in holding that inventory. It's not like you are producing the raw material or you are producing the final product and you are keeping outside the warehouse. Company ke bahar phek do. You are having, you are an owner of Audi. You are manufacturing a Audi A7 or A6. Manufacturing ho gaya, you are going, okay bhai ho gaya, just keep that car outside the factory. Anyone can take that car free of cost. ऐसा नहीं होता. They are always procuring in a we are having a CCTV cameras, we'll be having a security personals, right? So any final product or semi-finished products or the raw materials you cannot keep in open space. Fine. So they always have costs associated in carrying that inventory, or we can say in holding that inventory. That cost we call it as a holding cost. Okay, definition will be always be aage dekhen, we'll be taking the definitions also one by one. The basic idea will be understanding. Then last one is shortage cost. Shortage cost or stock out cost. What's the meaning of that? Let us suppose you are the owner of a pen manufacturing plant. Okay, and per pen you are getting a profit of rupees 10. But due to some reasons, you are not able to supply the pens in the market and you are not able to fulfill the demand. The demand was of 1000 pens and you are only able to give 900 pens. So there is a potential loss, the potential profit that could have made. You're getting a loss of 100 units, and for every unit you're having a loss of, let us suppose, 10 rupees. So 1000 rupees you're having a loss. So that loss that is being associated due to the stock out or shortage, that cost we call it as the shortage cost or the stock out cost. Is this clear? Kisi ko bhi, anyone having any doubt in any one of the four costs, please do let me know in the comment section. Anyone having any doubt in any four costs that you are seeing on your screen, please do let me know. Clear hai? Purchase cost, ordering cost, holding cost. Now let us take the definition. This is the basic idea. Let us take the, because देखो exam में you need to solve the question, है ना? Basic idea is you need to solve the question. Exam में problem होने चाहिए correctly, efficiently and quickly, right? Let's start with the first one, purchase cost. Already I have discussed the number of units, that means the annual demand. Let us suppose I'm taking the annual demand I'm denoting the annual demand as capital D, and unit price I'm denoting as capital C. So the purchase cost will be equal to D into C. Already I have taken an example with the help of an example. So number of unit into cost per unit, that will be giving you the purchase cost. Ordering cost, once again, definitely yaar, don't worry, aa gaya ordering cost. Okay, so ordering cost is basically you are purchasing this pen. Example that I've given you of Amazon. You are purchasing this pen. It is costing 100 rupees, but it is taking an additional charge of 25 rupees as delivery charges. So that 25 will be coming under the segment of ordering cost. When an inventory is purchased from outside the cost associated with bringing the inventory, like cost of tender, inspection cost, communication cost, processing cost, transportation cost, all the cost that is being associated in bringing this inventory to your warehouse. ऐसा नहीं है कि you are purchasing the diamond, let us suppose let's say gold. Okay, you are purchasing gold as a raw material. It is charging 50,000 rupees. If I say market scenario, 50,000 rupees for 10 gram. Okay, you only need to pay 50,000. It's not like this. You need to pay additional cost for transportation, for security also, because during the transportation there's a high chances of theft. You need to have a proper transportation security. So that cost associated in bringing your inventory to the warehouse, that cost will be called as the ordering cost. Okay. So ordering cost can be called as, ordering cost is equal to number of orders into cost for per order. Cost per order, let us say this is denoted as CO. I'm denoting this as CO, right? Now let us take an example. Let us suppose the annual demand is 12,000 units. Okay, annual demand is 12,000 units, and every time you are ordering 120 units. Okay, so tell me, in a year, this is per year, right? This is for 1 year, and every time you are procuring 120 units. So tell me how many number of orders you need to place in order to fulfill the annual demand. How many units you need to place the order in order to fulfill the annual demand? Tell me, number of orders kitna hoga? Number of orders. You're having annual demand as 12,000. In one inventory, one shot, मतलब एक बारी में you are procuring 120 units. So tell me how many orders you need to have in order to fulfill the annual demand. कितना order होना चाहिए? 10. No, it's not correct. 10 is incorrect, guys. Simple question. It is annual demand by this. Every time you are ordering 120 units, total annual requirement is 12,000. So number of orders will be 12,000 by 120, that is equal to 100. Right? Exactly. So how we are getting this? So number of order is equal to capital D by Q, where Q is the inventory level. Capital D by Q is the number of order. Okay, this is per year. This is yearly. Okay. So can you tell me after how many days? Let's say in a year I'm having 365 number of days. I'm assuming there is 365 number of days as the working days. I'm doing work for the entire year. There is no leave for me. So tell me after how many days I need to procure the order in order to fulfill this number of orders. कितने दिनों बाद I need to order? Tell me. This is number of orders, 100 orders per year. So what is the duration of one inventory? Tell me in days. Very easy. So this is 100 order in 365 days. So how many days is taken to complete one order? Are you able to get? So it is 3.65. The time duration is equal to 1 by n year, or I can say 365 by n year, that is equal to 3.65 days per order. That means after every 3.65 days, I need to place the next order. That means the next order should be there in the warehouse. After every 3.65 days, my next order should be present. Is this clear? Then only it won't be 36.5. It will be 3.65. 3.65 guys, not 36.5. After every 3.65 days, not place order. You should be receiving the order after every 3.65 days. Placing order is different. Receiving order is different. Is this clear? Fine. So can I say now if I want to write in years only, so it will be T is equal to 1 by n. So can I say T into n is always equal to 1? Because n is number of order, that is D by Q. T is the time period of a order, that is equal to Q by D. Okay, is this clear? Very basic. If I want to say in terms of month, if I want to say what is the time period in terms of month, it will be 12 by 100, 0.12 months. After every 0.12 months, you have to get the next order. Is this clear? Okay. Understood? Let us go to the next one, that is the holding cost, or setup is basically the same thing, number of setup into cost per setup. This is number of order, cost per order, exactly same. So if I talk about setup cost, this is inventory produced internally, the cost associated with bringing up the shutdown production system again into the starting position, cost of bringing the raw materials, arrangement of the worker, tool, equipment, etc. That will be coming under the number of setup. So it's basically the same. It's exactly the same. That is D by Q is the number of setup. Okay, same. Okay, but we need to concentrate on more on ordering cost, because you will be getting questions like this. So yeah, holding cost or carrying cost. What is holding cost? The cost associated in holding an inventory. If you are holding an inventory, definitely it will be getting some cost. Okay, let's say 100 rupees is required annually to hold 1 unit. Okay, so can I say holding cost is equal to average inventory for a period into holding cost per unit time? This is basically comprises of storage cost, handling cost, damage and depreciation cost. Now what is depreciation cost? Can anyone tell me what is depreciation cost? What is depreciation cost? Exactly, very good, Rohan. What is depreciation cost? Depreciation cost is, let us suppose 10 years back the gold was approximately or let us say internet package, let's take an example. 10 years back the internet package was like 500 rupees for 1 GB data. If you remember, for 1 GB data you have to pay like 800 rupees per month. Okay, fine. But in today's scenario you are getting every day 1 GB for a cost of like 400 rupees per month. Every day you are getting a 1 GB data. So that means you are having loss in the value. You are having a loss in value of the capital with time, because with the time the value of that product will be decreasing. Okay, let's take an example of an automobile. You are purchasing an automobile in 2002, let us suppose. Now in 2022, in 2022 your cost of that automobile has been depreciated, has been decreased. Okay, fine. So definitely that is your depreciation cost. Exactly, just like Surya is saying, with the time, what is a decrease in the value of a product you are having? That is depreciation cost. What type of question you can expect from this topic? Many questions, guys, many questions. EOQ problem will be spending after this. We'll be starting the EOQ problem. Okay. Yeah, shortage cost. This one is average your inventory for a period of time into holding cost per unit. And next is your shortage cost. This is average number of units that is short into shortage cost per unit per time. We'll be seeing this right now. We'll be seeing this right now by using the your EOQ model. So there are two models that we have to study. One is determination. In GATE examination, you are having this as a most important. Okay, all the EOQ models is basically coming under the segment of your deterministic. What is deterministic? In this, the demand rate is not changing. The demand rate is not changing. That means, let us suppose we're having 10 units per day as the demand rate, small d as the demand rate. So it is not changing throughout. If it is not changing throughout, so this we call it as deterministic model. In actual real life scenario, we are dealing with probabilistic approach. In this case, the demand is changing every day or after every 2 or 3 days. So in this case, this is a more sort of a real life scenario in which the demand rate and the lead time is changing. Okay, it is fluctuating. Okay, what is lead time will be understanding right now. Let's understand by using this demand rate only. So in this model, the demand rate and the lead time remains fixed, and this is no use of any safety stock. So what is safety stock? Let us suppose you are having this as the inventory level, this is the time. Okay, and every time you are having a production rate of, let us suppose, 10 units per day. Okay, 10 units per day के हिसाब से you are having this one, and the time duration is, let us suppose, 15 days. In every 15 days you are getting the stock out. So can you tell me what is the maximum inventory level? You are having a demand rate of, every day you are using 10 units per day. So at the starting, what was the inventory level? Can anyone tell me? At the start, in every day if you're using 10 units per day and you are having a 15 day as a time, cycle time, this we call it as cycle time. So can you tell me what will be the maximum inventory level that you will be having? Quickly, basic, simple question. 150. देखो भाई, you had 150 units with you. Every day you are using 10 units. After 15 days you will be having 0 left out with you. Okay, so यहाँ पे कितना था? You are having 150. Every day you are using like this 10 10 10 every day. So 15 day के बाद 0. Again you are having the next inventory. Okay, and again you are using with the same demand rate of 10 units per day. 10 units per day, right? And again we are having, so this kind of approach where the demand rate is not changing, this approach we call it as deterministic approach. Okay, and we are dealing with all the models that we are dealing with are coming under the segment of deterministic approach. Okay, is this clear? Now one thing we have just now read, that is lead time. Can anyone say what is lead time? Now it's not like this, like you are ordering, today is Wednesday, right? You are ordering your order on Wednesday and getting at approximately 12:30. You are ordering the order at 12:30 and getting at 12:31 the order is reached at your warehouse. Not possible. If you place the order right now, it will take at least 2-3 hours depending upon what is the inventory, or in some cases it will be taking a number of days. So the time at which I am placing the order, let us suppose I am placing, because I need my inventory to reach at this point, because at this point I am having a 0 inventory, I need to have a next inventory set to be coming into my warehouse. So the point where I am placing the order, let's say I am placing the order over here. Okay, so the point from this point till the end, which is having the inventory is finishing, this time we call it as the lead time. So what is lead time? It is a point from where I am placing the order, I am getting the order in my warehouse. This time we call it as a lead time. Okay, fine. And this level at which, this level of inventory at which I am placing the order, this level we call it as the reorder level. Is this clear? The time between placing the order and receiving the order, that we call it as a lead time, right? Okay, and the level at which I will be placing the order, this is we call it a reorder level. Let us take an example. Let us suppose I am saying lead time is equal to 5 days. Let us take an example. Lead time is equal to 5 days. So can anyone tell me what should be the reorder level? At what level of inventory I need to place the order? Simple. If lead time is 5 days, so tell me what will be the reorder level. That means what should be the level? It was having a 150 level. It was having 150 over here. Slowly it is decreasing. So tell me what should be the level of inventory such that my next order need to be placed. Simple. Quickly. 50. Okay. Perfect. 50. Right? है ना? 50. Sure. Simple question, guys. Very simple question. 50. 100. I'm getting some different responses. 150. देखो भाई, simple question है. देखो. See. At this point, what is the level of inventory? I'm having 150 units as a level of inventory. Daily, I'm using 10 units. So till this time, how much units I have used? How much units I have used? Can anyone tell me in the comment section? From reaching this point to this point, how much? This is 10 days. This is 10 days, right? So in 10 days, I am using 100 units. I was having 150 units. I have consumed 100 units. So what's the left out units with me? 50. So I am having a 50 units with me. So whenever my 50 units is being reached, I'll be placing the order so that at the end I'll be getting the next order. Okay, and this type of model, we call it as the Wilson-Harrison model or EOQ model. Very, very important. You are getting questions from this particular topic. Is this clear? So, and sometimes we are calling this as infinite replenishment model. Infinite replenishment model. Can anyone tell me why we are calling this to be infinite replenishment model? Because if you see, the moment my inventory is becoming zero, the same moment my inventory is becoming maximum. If you see this graph carefully, the moment my inventory is becoming zero, the same moment my inventory is becoming infinity, or that means maximum. That means the change in time is zero, inventory level is changing. That means I'm having infinite replenishment. Practically, it is not feasible. है ना कि just moment I am having the inventory zero and next second, fraction of second, my inventory is becoming maximum. Okay, not maximum, inventory. Is this clear? Right? Fine, understood what is reorder level. So I can directly say that reorder level is equal to demand rate into lead time. Simply. Okay, this is the demand rate and this is the lead time that we are having. This is the lead time, right? This is the lead time and this is the reorder level. Reorder level. Okay, and this is a very basic model. Maximum questions, 95% of the questions is coming from this particular model. Okay, done. Chalo, let's now calculate the individual values. Now we have seen basically 4 costs: purchase cost, ordering cost, holding cost and stock out cost. Here I won't be having any stock out because it is a deterministic model. We know that every day we are having a itna amount of inventory, right? It is becoming zero, then again it is increasing, right? So in this type of model, where in deterministic model, no safety stock is required. No safety stock is required. Why it is not required? Sir, I know that every day we are having a fixed demand. It is not changing. That is a deterministic model. So at this point of time, it will be again, you'll be getting the next inventory. It will be using again next inventory. It will be using. So that is not at all required. But the same thing if I talk about probabilistic model. If I talk about probabilistic model, yeah. Chalo, let us take here only. If I take, if I take the probabilistic model, in this case, what is happening? In this case, if you see, sometimes the demand is like this. Perfect. Okay. sometime this is the reorder level. This is the reorder level. Sometimes the demand is slightly fluctuating. Okay. Sometimes the demand is fluctuating. So in this case, it is let's say D1. This is D2, D3. So here the demand is changing. So in this case, whenever we are having fluctuating demand, I always need to have some safety stock with me. Okay, so I always need to have some safety stock with me, so that safety stock should always be there, so that your fluctuating demand and lead time can be fulfilled. In this case, your demand is fluctuating. In this case, if you see, it is going beyond this level. So I should always be having some safety stock. So here I can say this is reorder level. So in probabilistic model, reorder level should be equal to your D into lead time plus the safety stock. Or I can say, instead of this, I can write, because this is for a single. So I can say this is average demand during lead time. During lead time. Okay, so I won't be using this one. Instead of this, I will be using, because this is a probabilistic approach, so this will be Z into sigma, and this is your average demand during lead time. So that is a separate thing that we should be having. So the safety stock should always be considered in a your probabilistic model. But if in the problem they are giving safety stock, then you need to take into account. In some questions in deterministic also they are giving the safety stock value, so you need to take into account that value. Okay, now coming back to this, let's start with the first cost, that is the purchase cost. Purchase cost, that is equal to annual demand into the unit price. Perfect, no problem with that. Next is the ordering cost, annual ordering cost. Annual ordering cost, that is number of order. What is number of orders? D by Q, number of orders, into cost for one order, that is D by Q into CO, right? Now let us talk about holding cost for time period T. Let us say holding cost for time period T. How to calculate that? Because T is the time period, this one. This is the time period. This is one time period T, then having the next time period T, this one. So what is the cost associated? That is the average inventory. So I'm having, what is the average inventory? What is Q average? Q average is equal to, maximum is this Q, minimum is 0. So Q plus 0 by 2. So average inventory is Q by 2. So I can say this is equal to Q by 2 into cost for holding the item for 1 minute for 1 year, and this is for one time period T. This is for the time period T. This is I'm calculating for the time period T. If I want to calculate for the this is for one order. This is for time period T, that means for one order. I need to calculate for the entire year, that means I need to multiply it with by n. Then annual holding cost will be equal to Q by 2 into CH into T into number of orders. What is N into T? What is N into T? Already we have discussed this. What is N into T? Look, already we have discussed. It is always equal to 1. So N into T is always equal to 1. That makes the annual holding cost to be equal to Q by 2 into CH. In some textbooks, they will be directly giving you Q by 2 into CH, which is not appropriate. You need to calculate for the entire year like this, T into N, that is equal to 1. Okay, so now what we have seen, that this is the total cost associated. So I can say total annual cost, or I can say TAC, that is equal to purchase cost plus ordering cost plus holding cost, that is equal to D into C plus Q by D by Q into CO, D by Q into CO plus Q by 2 into CH. So this is the total annual cost that is being associated with the inventory. Now, there are three costs that you are seeing on your screen: purchase cost, ordering cost, and holding cost. So tell me one very important thing: which cost is independent of inventory? That means how much inventory I am procuring, it is not depending on that. In these three costs, tell me, purchase, holding, or ordering, which is independent of inventory. That means if I am procuring 100 units as inventory or 12,000 units as inventory, it is independent. Tell me. It is nothing but purchase cost. If you see, it is independent of inventory. This purchase cost, it is independent of inventory. It is independent of Q, right? So can I say, if I introduce one more cost, that is total inventory cost or total variable cost, that is equal to your holding cost plus the ordering cost, and that is equal to Q by 2 into CH plus D by Q into CO. Okay, is this clear? Understood? Now if you observe the holding cost and ordering cost, if your inventory level is more, which cost will be higher, ordering cost or holding cost? That means if your Q is increasing, so definitely the holding cost is going to increase. You can see from the relation, Q is directly proportional to the holding cost. But if I talk about ordering cost, if you are increasing the inventory level, that means number of orders will be less. Let us take this example. The annual demand was 12,000. Okay. In one case, in case number 1, I am having an inventory level of 1000 units. Okay. In case number 2, I am having an inventory level of 120 units. So tell me, what is the number of order in case number 1 and what is the number of order in case number 2? Quickly. If you see, annual demand is 12,000. You are procuring 1,000 units for every time. So number of orders will be 12. 12 orders per year. Right? If you see in this case, you are procuring 120 units. So every time, so you have to go for 100 number of orders. Units का ध्यान बहुत जरूर दें. Always try to take. Always try. Exactly. 12 orders per year, this will be 100 orders per year. So if you are having more inventory, so your number of orders will be less. Simple. If you see here, I'm keeping an inventory level of 1000 units. You have to order only 12 times. Here the inventory level is 120, that means less number of inventory. I need to have a large number of orders. So if large number of orders, that means your ordering cost gonna rise. Is this clear? Okay, so one is directly proportional, one is inversely proportional. So if I plot one graph, so we are having this as cost, this is inventory level, that is Q, right? So one is directly proportional, that is your holding cost, and second is inversely proportional, that is your ordering cost. So there will be a point where your cost will be minimum. Okay, at this inventory level we call it as Q star or EOQ. That means economic order quantity. Okay, this will be called as the economic order quantity, where you will be having the minimum cost, because one is increasing with the inventory level, second is decreasing with the inventory level. So in between there will be a point where the cost will be minimum, and that cost that inventory level or that inventory we call it as the economic order quantity. That means in order to have a minimum cost, you should be having a minimum or Q inventory level should be Q star. Then how to identify, how to calculate this Q star? So what we are doing is, look, what we are doing, we are going for a Q star, right? Let us take a note. What we are doing, the total inventory cost, that is equal to holding cost plus ordering cost. So for minimum cost, what I do, I try to differentiate this total inventory cost with respect to the inventory level and make it equal to 0, right? Right, you differentiate this. What is holding cost? Holding cost is Q by 2 into CH plus D by Q into CO. You differentiate this equation with respect to Q and make it equal to 0. What you are getting is, you are getting Q star, that is your EOQ, that is equal to 2D CO by CH under root of this. So this is your economic order quantity, Q star. This is your economic order quantity, that is Q star. Okay, fine. And one thing, if you see from the graph, if you come back through that graph, if you see, very important, interesting point. Can we say this EOQ is a point where your holding cost and, can we say EOQ is a point where your holding cost is exactly equal to ordering cost? Can we say like this? Can we say at EOQ your holding cost and ordering cost is exactly matching? So can we get the same relation? So let's check. Are we getting the same relation? What is holding cost? So I can say at EOQ your holding cost is exactly equal to the ordering cost. What is holding cost? Q by 2 into CH, that is equal to D by Q into CO. So this is Q square is equal to 2D CO by CH. So Q is equal to 2D CO by CH under root of this. Okay, so basically I am getting the economic order quantity. We are getting economic order quantity, right? So corresponding to this, do we have a total inventory cost? So what is TIC? TIC is equal to holding cost plus ordering cost, or I can say 2 times of any one of the costs, holding cost or 2 times of ordering cost. So if you place this value, TIC star 2D CO CH under root. No, Surya, it is 2D CO by CH under root 2D CO by CH, right? Is this clear? Fine. Because basic is clear, then we'll be accelerating. Okay, Ramesh Mohan, if basic is clear, then it will be very easy for us to understand production model and everything. So I'm spending more time on basics so that we can accelerate our speed, right? Chalo. So what we have calculated, the total annual cost, D into C, which is constant, which is independent of inventory, D by Q into CO, that is the ordering cost, this is the holding cost, right? So we have calculated total variable cost or the total inventory cost, both are same, and from here we calculated the EOQ, right? Is this clear? Is this clear? Now, if I'm saying what should be the optimum, if I say what will be the optimum number of order, if in the question they are saying what is the optimum number of order, what is optimum number of orders, that is N star, can anyone say? So what is optimum number of orders? You know the annual demand, you have calculated the EOQ, so D by Q star will be the optimum number of orders. Usually questions is getting from this particular topic. Okay, optimum number of orders is D by Q star, right? Now Next kind of model that you are expecting in the question is a discount. Now, what is this discount? Now, you have seen in different shopping malls, you purchase one jeans at 1,000 rupees. If you purchase two jeans, you'll be getting 10 rupees, 10% off. You purchase 5 jeans, you'll be getting 1 jeans free, right? Is this clear? So this kind of model, it is very useful in price break or discount model. So let us take one example and let us try to understand with the help of this example. Okay, this is the question, very basic and very easy. Consider the following data. Annual demand is given to 2,500 units per year. Ordering cost is given. Inventory holding cost 25% of the unit price. Usually holding cost is given in percentage time. It is usually always given in percentage of the unit price. They have given 25% of the unit price. Now the question is, if you are having an order quantity of 500 or less than that, unit price is 10 rupees. If you are ordering more than 500, greater than equal to 500, your unit price will be 9. So the question is, what is the optimum order quantity in units? Tell me. Just like buy one get one free. Yeah, exactly. So what should be the optimum number of order? Now whenever you're getting a question like this, like discount model, first of all, see the EOQ for the lowest unit price. This is the lowest unit price. Calculate Q star. Calculate the Q star 2D CO by CH. So for this, CH value will be, D is given. This is your annual demand, capital D. This is the ordering cost, CO. This is CH. Now CH value will be equal to 0.25 of 9. Okay, so tell me, what is the value of Q star you are getting? CO value is 100 divided by 0.25 of 9. Approximate value, just tell me approximate value. Anyone who has calculated this value? Approximately, what is the value of Q star you are getting? This is the EOQ model that we have calculated for the lowest unit price. What's the value? I think I've also calculated that value. It should be somewhere around 447. 447, somewhere around 447. Now, in order to avail a unit price of 9 rupees, I need to have minimum 500 units, right? Fine, but I am getting a 447. That means, is this a feasible range? This is not feasible. This is not feasible because in order to avail a unit price of 9 rupees, minimum your order quantity should be 500. So this is not feasible. Practically, it's not feasible. So let us calculate EOQ for the next price break. So Q star for the next price break, that is 2 into D is 2500, CO is 100. Now the unit holding price will be changing, 0.25 of 10. So tell me, what's the value you are getting? Approximate value. What is the approximate value? Quickly. 447.471. Okay, 471. Both ways you are having not in the feasible range. This one will be 447 approximately. Now this is feasible. This is feasible. Why it is feasible? Because they are saying if your unit number of units is less than 500, your unit price will be 10, and that is exactly matching with our answer. So what should be the optimum order quantity? Is it 447? No. We have to cross check. How we need to cross check? We can cross check by calculating the total cost at the threshold value, because if you are ordering exactly 500, I can have a lower than that of this EOQ. So let us calculate the total cost. Let us calculate the total cost at 447 approximately. What's the value? 447.21, right? Okay. So 447.21. So TIC 447.21, that is equal to D into C plus 2D COCH under root. So annual demand is 2500 into unit price is 10 plus 2 into 2500 into 100 into 0.25 into 10 under root of this, you'll be getting one value. Next value you'll be getting at 500 at the threshold value. So total cost at 500 will be equal to D into C, that is 2500 into 9 plus D by Q, 2500 by 500 into CO plus Q by 2 into CH, 0.25 of 9. What is the total cost that we are getting in both the cases? If you calculate, this will be approximately 26,118 approximate, and this will be approximately 23562. Now if you clearly see, if you are ordering 500 units, your total cost is 23,000, and if you are ordering at the EOQ of the first price break, the first one, you are getting 26,000. So definitely your optimum order will be, what should be optimum order? Then your optimum order will be equal to 500 units. This will be your answer. 2 marks problem, gate examination point of view. 2 marks problem, gate examination point of view. ठीक है, very important question इसमें से पूछा गया है, so make sure you are not having any doubt. Let me tell you graphically what is happening. Let me tell you graphically what is happening. देखो, this is the inventory level Q, that is the we can say cost. Okay, so what is happening? This is the first price break that we are having, something like this. Okay, this is the EOQ, and that was 447, and it was costing me rupees approximately 26,000, 26,118, something around this. But if I'm going for this price break, what has happened? When I go for a price break, you are having a price break like this. Okay, let me just go for a dotted line like this, and it is having an EOQ at 441, something like this, 471, which is not feasible because it is feasible. This price break is feasible at 500 rupees. That means, what's the meaning of this? The meaning of this is your complete graph is something like this. This is your price break and this. Okay, and this is the point where we are having that minimum price, that is 23,562, something like this, 23,000. Is this clear? Fine, because we have seen every total cost will be having a graph like this. This is the minimum, that is EOQ, Q star. Okay, for this second price break where the unit price was equal to 9 rupees per unit, for this case the EOQ was located somewhere around where, which is 471, which is not practically feasible because for that your 500 is the threshold value. For first price break, unit price is 10 rupees. Okay, for that EOQ was defined, that is 447, which is less than 500. Is this clear? Very important. Many of the students are not able to understand the price break or discount model. Is this clear? First what we have did, if you see this question, in this question, first of all, we calculated the Q star for the first price break, the lowest unit price. We were getting 471, right? For if you see, and which is not feasible. So what we have seen, 471 is the price EOQ for the unit price of 9, which is not feasible because this is only feasible after 500 only. After 500 only it is feasible. So practically it is not possible. So what we have did, we have gone to a then we calculated for the second one. We got 447, which is feasible, less than 500. This is actually feasible, right? So we plotted this. So for this one, the first price break where your unit price is 10, we are actually getting a EOQ. So corresponding price is 26,000. Okay, so what we have did, we compared this value, we compared this total cost at 447, which is 26,000, with a threshold value at 500, that is 23,000. So here This is the point where we are getting the 23,000. Is this clear? Understood? Very important. बहुत लोगों को समझ ही नहीं आता. Let us take a scenario. If in the same question, if this Q star, if this comes out to be 510, then what is your answer? Let us suppose at unit price 9, you are getting Q star as 510. So what is your answer? Anyone who can tell me? Your answer will be 510, because that is a EOQ for this point, which is a defined value. And then at EOQ, we are getting the minimum cost. So no need to check for other values. Not at all required. 510 is your answer. Is this clear? Very, very important. Understood? Clear? Now let's go for the next model. That is your production model. Now let's go for the next model, that is production model. Okay. Now in production model, what we do, we try to produce the raw material inventory in the warehouse only. Okay. In production build-up, what we do, we are not procuring any inventory, we are manufacturing the inventory in our system. Is this clear? Just like the tires example, automobile tires example, we have already discussed. All the automobile company, they are not manufacturing tires, they are procuring the tires directly from the vendor and they are installing it, right? Let us suppose in your automobile company, you have planned that I will be manufacturing the tires in my own system, right? So this type of model is applicable where we are manufacturing the inventory. Okay, so there is a production going on. So let us suppose small p is the production rate, and small d is the demand rate. This is exactly the previous one, but now slightly changed in the graph that you will be seeing in this case. Exactly this setup only, we call it as setup. Okay, we won't be having any ordering cost here, we'll be having the setup cost, right? So tell me, production rate and the demand rate, which will be higher? Practically, if it is feasible, production rate should be higher than that of the demand rate, right? Production rate should be higher than that of demand rate. Let us suppose I am producing 10 units per day. I am producing 10 units per day and demand is let us just say 6 units per day. Okay, so definitely every day I am storing 4 units. Every day I am storing 4 units. On a daily basis, 4 units will be stored and we will be having some holding cost for that. Right? Is this clear? So let us try to draw the graph. Let me draw it for you guys so that we can have a clarity in this. Black one. This is your inventory level Q. Sorry, this is the time. Inventory level. This is the time. This is inventory. Right? Let us suppose I'm having red lines. This is the daily demand, which is constant because I'm dealing with a deterministic model, right? I'm producing this one. This is the total time. This is the total time, right? This is the maximum Q level, that is Q value. This is, I'm only producing till this point. Okay, this is the production level P. This is the time of production TP. I'm only producing for the few time period because that is not required. So effectively, what is the net consumption rate? Net consumption rate will be P minus D. net consumption rate will be P minus D. This is P minus D, right? And this is your demand rate D. And this is the maximum, actually the maximum inventory level, that is QM. That is the maximum inventory level. Okay, QM is the maximum inventory level. Do you see not comfortable? 1 second, let me. Now, okay, white background. Fine. So actually you are having a maximum inventory of this much only, that is QM. Because if you take that example, production rate was 10 units per day, 10 units per day, and the demand was 6 units per day. So what is the net consumption rate? P minus D. So every day 4 units is being saved. So every day 4 units is being stored. 10 minus 6, every day 4 units is being stored. So at max you can have P minus D into TP, that is the maximum production rate. So can I say QM is equal to, P minus D into TP? Yes. Okay. And also can I say Q is equal to, this is the production rate till this point, that is capital Q for the time period P. So P into TP. Take the ratio of these two equations. So I can say Q is equal to QM into, or I would rather say the reverse one. QM is equal to P minus D by P into Q. Yes or no? Many students are not having a comfortable in this particular equations. They are just remembering the formulas, which is not appropriate. Okay, fine. So let us now come back to our production build-up model. So here what we have seen, this is the production P, right? This is P minus D. This is the maximum inventory level, that is QM. Right? This is the demand rate D every day from this point. This is the demand rate. So in this case, we will be having the reorder level. Same explanations, are not going again and again to that. Right? So what we have seen that Q is equal to P into TP, and QM is equal to P minus D into TP. So from here, I have calculated QM is equal to P minus D by P into capital Q. So what will be the total your purchase cost? Everything that will be same. Purchase cost, annual demand into unit price, same. In this case, now won't be having the ordering cost, will be having the setup cost, annual setup cost. That will be equal to D by Q into CS, right? That is the setup cost. Next is a holding cost. Now holding cost is basically average inventory. Now what is the average inventory? What is the maximum inventory? I'm having QM as the maximum inventory. We're having 0 as inventory. So what will be the average? Average will be equal to, Q average will be equal to QM plus 0 by 2, right? So that is equal to QM by 2. What is QM? QM is equal to P minus D by P into Q. So this is P minus D by P into Q. So your annual holding cost, I'll be going directly to the relation now, because already we have done this exercise in EOQ model also. So it will be Q by 2 into CH P minus D by P. Is this clear? So at EOQ, what is happening? Right? at EOQ, what will be having? So this is the total inventory, the total variable cost or total inventory cost that we are getting P minus D by P, right? So at EOQ, we have seen that the cost is minimum. So we differentiate that. Again, I'll be getting a relation like this. Q star is equal to, write the same relation, 2DCO by CH under root of this into under root of P upon P minus D. Okay, so this is the EOQ for a production based model. How to remember? Dekho, it's a very students are asking, sir, how to remember the formula? You tell me one thing. If you are trying to produce the inventory into a system, so definitely it will be a profitable value. Okay, so tell me P upon P minus D, it is greater than 1 or less than 1? P upon P minus D, greater than 1 or less than 1? It is definitely greater than 1. So Q star for production model will definitely higher than that of the Q star for a EOQ model. So it is less than 1. So if I want to write TIC star, it is under root of 2DCOCH into the cost should be less. The cost should be less. So it will be P minus D in the numerator and P in the denominator. Yes. So this is the total inventory cost for the EOQ. Is this clear? Easy way to remember. Easy way to remember, right? चलिए जल्दी से, quickly, done. Easy way to remember the formulations. Very easy. So easily you can understand. The formula is same, exactly same. But only thing that is, this is your production factor, P upon P minus D. So it is greater than 1 for Q star and definitely less than 1 for the cost perspective. Is this clear? Understood? The same thing I have written. So let us take one example and quickly you will be telling me the answers. Quickly, I need quick answers. I need quick answers. Consider the following data with the reference to elementary deterministic economic order quantity model. What should be the total number of economic orders per year to meet the annual demand? Very easy. They're asking you simple question, N star. They're asking you N star. Right? For calculating N star, you need to get the value of Q star. Q star is equal to 2DCO by CH. Right? Everything is given. You can calculate the value of Q star. This is annual demand. CO is ordering cost is 30 and inventory carrying cost is 1.5. Place the value getting Q star. So you can calculate N star, that is equal to D by Q star. Very basic question, easy question. Done? Clear? Done? Chalo, let's proceed. Now you can easily calculate. You will be getting this value to be 50, around 50. That will be your answer. You will be getting answer to be 50. This will be 50, right? Chalo, next. The last topic of today's session is sequencing. It will take hardly 10 minutes. Then we'll be closing the session. Part 1 will be over. So tomorrow we will be having a detailed discussion on linear programming, forecasting, queuing theory and rest topics. I will be firstly concentrating on these 3 topics, right? Then I'll be switching to the next topics. Is this clear, everyone? Done? Sequencing बहुत easy है, very easy topic. So shall we proceed? Anyone having any doubt or difficulty? Please do let me know. Done hai? Yes? Chalo. I think everyone is now, already we have covered. Yeah. 2000. Yeah, you'll be getting Q star is equal to 2000. This will be approximately 2000. You divide it, we'll be getting 50. Done. Stockout model. Chalo, ek baar let us discuss that also. Stockout model, because some one or two times they have asked. तो वो भी कर लेते हैं. Let's calculate. Go for the probabilistic also. Let us understand this probabilistic model also. Now in this probabilistic model, already we have seen we are having a fluctuating demand. Fluctuating demand rate and lead time. Hai? In this case, nothing is fixed. So in this case, we need to have some safety stock. Safety stock is mandatory. Safety stock is mandatory. Right? Yes or no? Safety stock is mandatory, or I can say compulsory. Okay, fine. So in this case, safety stock is mandatory because your demand rate is changing, your lead time is changing, so it is very much mandatory to have a safety stock in probabilistic model. So in this case, we are having a optimization, or we can say probabilistic model. In this case, we go for a cumulative probability, we can say stockout model. Okay, we call it as a demand profit model. Now let us take an example, and it is being used in the perishable items. You have I think you have studied about perishable items. What is perishable items? Perishable items are basically which are having very less time, or life cycle is very less. Best example like bread, packet of milk, you're having a life time period of 2 or 3 days. Okay, so this kind of model is being used in a perishable item model. Basically, engineering service point of view is slightly important. Gate perspective, 1 or 2 times they have asked a question, so let us discuss that also. Let us suppose the cost price of a product is 10 rupees. Okay, the cost price of a product is rupees 10, or unit price is 10, or selling price is 10 rupees. Okay, exactly. And let us suppose you are not able to fulfill the demand. That means your demand is greater than supply. If demand is greater than supply, right? If demand is greater than supply, then what will happen? 100 units was required, 100 units is the demand, and you are only able to fulfill 60 units. So there is a shortage of 40 units, right? So that 40 units could have been converted into profit. So I can say this is a potential profit that could have converted into loss. Let us suppose the demand is 100 units, and the supply that you are able to provide is only 60 units, right? So you are having a shortage of kitna? 40 units, and per unit the selling price is 10 rupees, and in every you are having a profit of, let us say, 2 rupees of profit. So I could have a 80 rupees profit, but due to the shortage of supply, this profit has been converted into a potential loss, potential profit that is converted into loss. Okay, is this clear? So can I say the net profit is equal to the selling price minus the unit price, or the we can say cost price of a product, minus, or we can say plus the cost which is associated in losing a product. That means I would rather say where SP is the selling price, SP is the selling price, C is the cost price, right, and CB is the potential profit that is converted into loss. potential profit that is converted into loss, potential profit loss, right? So SP minus C plus CB, that is the total profit that could have been came into my pocket, but due to the not able to fulfill the demand, this is the potential profit which is converted into loss. We can have one more scenario. Let us suppose your supply is greater than the demand. Your supply is greater than demand. Then what will happen? Let us suppose you are having 100 units of milk packets is there in your shop, but only 60 units is being consumed. There are 40 units that is being total waste, or we can say will be having a scrap value, right? Because you cannot consume the milk product after certain days. Okay, fine. Is this clear? CB is basically potential profit, or we can say shortage cost. Let us say this is shortage cost. Shortage cost. Okay, this is the net potential profit that would have been converted. Is this clear? Fine. So I can say, let us suppose I'm having 100 units with me, and only 60 units is being consumed. Only 60 unit is being consumed. So we are having 40 units, which is total scrap. It is having a scrap value because I have to sell off that in scrap value. Let us suppose I am taking the cost price was 8 rupees and I'm selling this at 2 rupees. I'm selling at 2 rupees, right? I have purchased that milk product. I was selling at 10 rupees. The selling price was 10 rupees, but due to the your excessive units that is being, because your supply is greater than that of demand, so in this case I'm taking a scrap value of 2 rupees. That means I'm selling this at rupees, let us say 6. I'm selling this at 6 rupees. So I'm having a scrap value of, let us say I'm selling at 2 rupees, right? So this could have been sell off at 10 rupees with a profit of 2 rupees, but I'm selling this at 2 rupees with a net loss I'm getting is 6 rupees. So I can say the loss due to excessive supply over demand, that can be written as the cost price minus the scrap value, the cost price minus scrap value plus why we are holding also. Is this clear? Is this clear? So can I say your P is equal to the selling price minus cost price plus the shortage cost. The loss is equal to the cost price minus the scrap value plus holding cost. So by taking this value P upon P plus L, probability of n minus 1 less than equal to probability of n. So by using this relation, I will be able to obtain the optimum stock level. Okay, बहुत rarely question is being asked from this topic, बहुत rarely. We'll be having a table, probabilistic table. We calculate the cumulative probability. We calculate the cumulative probability. Okay, from there you identify in which range it is being lying. Let us suppose आपका probability of point, let us take an example like this. I'm having let's say 0.8, 0.95 and 1, because cumulative will be always be 1. I'm having a value of P, this value to be P upon P plus L. P upon P plus L, this value is coming out to be, let us suppose 0.93. So it will be in between these two value, and this corresponding, this will be given the problem. Let us suppose the unit level is 10, this unit level is 7. Okay, so your range is in between these two ranges. So your answer will be this one. 7 is the optimal because it will always be less than equal to the higher value. So higher value is this one. So this will be the answer. So it's very we can say probabilistic approach, very rarely asked, right? So you can solve. There was one question in 2003 or 4. The question was asked, right? So you can calculate directly by using this optimum stock level. You can calculate. Okay, and this is basically used in perishable items where the life of the item is very, very less. Probabilistic model. Okay, clear? Stockard model not required. I'm not taking that into consideration because Stockard model ESE point of view important hai, not GATE point of view. Yes, but important topics from inventory is your basic EOQ model and the your production based model. These two models are very, very important, and discount model also. We have taken a question from that topic, right? So we are left out with sequencing. I think we have taken a lot of time. So what we do, we will be continuing the next topic, that is sequencing, in the tomorrow session, that is part 2. We'll be studying linear programming also. We'll be solving one question from the simplex method because many students have texted me, sir, please do a session on simplex method. So what we do, we try to start from linear programming, okay, and after that we'll be going for sequencing, then forecasting, then queuing theory, and simultaneously we'll be covering. Along with that, we'll be solving some questions also, right? There's one homework question I would like to give you. Please try to solve this question and you can write in the comment section. We'll be having this question. Discussions will be done in the tomorrow sessions. This is a homework problem for all of you. It's a question from the crashing model. What is the minimum cost project duration in days? Okay, make sure you are solving this question, and we'll be having a discussion on this problem tomorrow at 10 a.m. Okay, so kal milte hain. Let's meet tomorrow and discuss about more interesting topics, that is linear programming. बहुत students को problem आता है this topic में, that is linear programming. So we'll be discussing that topic. We'll be starting from linear programming, then we'll be going to switching to because linear programming will be taking approximately 1.5 hours. Then rest topics are very short, half hour more than sufficient, half or 1.5 hours more than sufficient. Okay, so please try to solve this question. Write your answer in the comment section, and yes, we'll be meeting tomorrow, same time, same channel, इसी एनर्जी के साथ. Please try to solve some questions for more clarity, and the PDF I think will be shared on that particular Telegram channel. Okay, fine. So thank you guys for joining with me. This is Suraj Kubi signing off. Make sure everyone is practicing. This is the last Maha Marathon is going on. Give your best, and in evening Dheeraj sir will be coming with a very important subject. I hope so you know production engineering, right? Thank you guys. Bye bye. Take care. Stay safe.